The amount of failed Loxone projects that I've taken over in my time, I mean, I've lost count now. And I know so many other credible installers that have also lost count. Look, there's this one, there's that one, this one, look at this one, this, oh my God, take a look at that. Just what absolute disasters. And it usually comes down to a couple of things. One, just piss poor planning or none at all. And two, a lack of understanding when it comes to the correct project delivery process. Anyway, in this video, I'm going to take you through a real world Loxone smart home project. And it's not this one that you see behind me. Although I have added a mini server and an audio server, I had to butcher my workshop panel to take this mini server out of, just so I look credible. But the project that you're actually going to be working through is, the panel is here somewhere on the screen. This is a demo project using a KNX system here. So these are just props, guys. But the real world Loxone smart home project that I'm going to take you through in this video was delivered to a real client over the course of 23 days. So the full control panel build process of 2 panels. There was a main panel in the plant room and then a sub panel in the garage, and then making sure that they're ready for site installation. And as I mentioned, that 23 days, I actually tracked every single minute spent on this project over the course of a year, which came to a total of 184 hours, which is 23 8-hour working days. Now you're probably wondering, who is this Loxonaut? And I can call myself a Loxonaut because I actually worked at Loxone UK for a year and a half as a partner coach and on the technical support team, supporting Loxone's partner network of electricians and engineers with specifying design and programming before I left to start my own business. And you can check me out on LinkedIn. There should be something on the screen right now. So look, if you're someone who is interested in Loxone for smart homes or commercial building automation, and you want to get off on the right foot, i.e. delivering professional, profitable projects that don't turn into those takeover projects, then it might be worth watching this video first. Okay guys, so now on to the build of the control panel. So we should all have our documentation printed out. And then the first thing, if we're working with the future automation panels, the first thing I do is prep the panel. So what do I mean by that? So firstly is taking all the covers off, arranging the earth and neutral points depending on whether it's top cable entry or bottom cable entry, and then also arranging the DIN rail. So let's get cracking with that now. Okay, so prepping the panel. So as you can see, the first thing I do is I just get the door off. So removing those pins, and I take the cover plate off, take all the trunking lids off. And then here, what I'm doing here, and I'll show you some images, is I'm adjusting where the default earth bar and neutral bar are located. So they're always put, you know, at the top or the bottom when you get these future automation panels, but that might not necessarily tie into where you need them. So I'm actually, you can adjust them and move them. You got like all these little holes in the back plate so you can move where they are. And then also, as you'll see in a second, I start adjusting the DIN rail. So you can see they're all raised up at the moment, but sometimes, like, you keep them raised up if you've got like modules or MCBs, RCBOs that are going to be poking through that cover plate that I took off initially. But if you've got like terminal blocks, power supplies, you know, that you don't need to get to, that you want to stop people sticking their fingers in, you can mount the DIN rails to the bottom and then put a blanking plate on, as you'll see in a minute. And then on some of them, I want half of them raised and then half of them at the bottom here. And you'll see as the project progresses why that is. So yeah, that's the initial prep done. And then also you want to snap the finger trunking. So let's come over here and see what we got image wise. I absolutely love that. You know, when you've got all of your components, you know, you're not waiting on anything. They're all laid out ready to be put into the panel. Absolutely, don't know what it is. I absolutely love that. So yeah, so taking off the door, so we're removing those pins and these little O-rings that hold them on. There we go. They're just little rubber O-rings. This is that plate that I was talking about. So we stepped the DIN rail to the back without using those standoffs here and up here, because it's a bottom cable entry panel. So we got terminal blocks on the bottom. We don't want people sticking their fingers in there. And then we got power supplies up the top. And then these other rows, we've got a combination, well, mostly controllers, modules, and on the top row we got some RCBOs, of which you'll see. Those are like blanking plates, or blanks if you put the blanking plates on. You'll see that later. Obviously a screwdriver to remove those bits. And then the other thing which is a little bit annoying about these panels is, because I'm mounting things on this, like PSUs on this top bar, which will be dropped down, but there's no trunking going across here, which is really annoying. Actually, these panels in general from Future Automation, here we go. They are good because they're obviously prefabricated, but they do have their limitations. That being one of them, and also just the trunking isn't really doesn't always have enough space. But I get that they're limited on space. But they are, all in all, they're really good panels. But yeah, so this is where you can find them if you're looking for the Loxone KNX ones. These are the ones that I'm using in this project. Yeah, that's where you get them from. Right, moving on. And then I just always have a pot with all of my little odds and sods. Yeah. You get 2 blanks or 1 blank that will be used, across the bottom one and the top one. And this is kind of what it looks like with all the trunking lids on. We want to take those off because we're about to start wiring it. And then we want to snap those fingers. And just to give you some context, what it looks like when we're ready to ship. Actually, let's go back. Lox 1 we're working on here. But so you see what I mean. We got that blank plate across the top because that's where the PSUs are going. And then we got a blank plate across the bottom because that's where the terminal blocks are. And then we're going to get like a 2/3 blank plate here, but I needed to order it because we've got PSUs mounted here. But then we want access to the RCBOs. And then we've got all our modules that are sticking through here. And you can see we can use modular blanks here when needed. We're also by a blank plate that is like a 3 or 1/4 blank. Yeah, so that is it for that video.
Okay guys, on to the next step now, and that is to populate the panel. And pretty self-explanatory, we're just going to add all the components into the enclosure, and we're also going to make sure that everything's labelled as well before we start wiring it.
Okay, on to the next video, and we are recording this time. I've already shot this video, but it didn't record. So this one's pretty self-explanatory really. It's me just adding all of the components, all of the modules, all of the extensions to the panel. Now the panel's been prepped, we can just add all of the components and then start labeling them ultimately. So you can see here the top row of these PSUs, that's sitting on the DIN rail that is fixed to the bottom, like these ones here. But then all these other ones, they're raised up because we need to, well, it's nice to see what's on the front, the lights on the front of these modules. We need to access the RCBOs.
And then as you can see down here, I'm adding all the terminal blocks based on the terminal block layout that I've already sort of designed and been through. What you're seeing me add here is, yeah, they're fused terminal blocks, but I think that changes slightly later on. We still have fused terminal blocks because we want to be fusing, even though it's 24-volt DC, we still want to be fusing the outbound cables and protecting those cables. Like if there's an overcurrent, you know, there's no risk of fire, you know, the fuse is going to blow and it's all safe. So we don't just do that for, you know, mains voltage, 230-volt AC. We also want to do that for any DC voltages as well. But I think I also later on, I change where these fused terminal blocks are and move them up here. And then here we have some distribution for the 24-volt DC and the 0-volt DC. What you can see here is I'm just adding the labels. So I'm using a Brother printer down here, really good piece of kit, and just, yeah, labeling everything. So yeah, did the PSUs all to the same size, same standard, same font size. Now you can see I'm doing the same thing with the RCBOs, and then I'll be doing the same thing for all of the modules as well. So like mini server might be MS, dimmer extension might be DE1, DE2, relay extension RE1, etc., etc. So yeah, you can see that's what I'm doing here. Cool. So let's now have a look at the images, and just following on from what I mentioned on the previous video. So you can see I'm breaking the finger trunk in. This is now, as you can see, where I've dropped down the DIN rail at the bottom, at the top, and then half of the one on this second row. So you can see here that's now ready to go, and always worth keeping any spare parts, any bits, obviously that are going to be used later on to finish things off, but also just spare parts. You know, if you do another project in the future, it's good to have these bits, because it might be that you lose bits, and if you've got spares, you know, it might be that you need another buzz bar, whether it's for an earth or a neutral. You know, you've kept those components. So yeah, here we are, ready to wire everything. I don't think the labels are on there, but yeah, it's really satisfying when everything's in place, ready to wire. This is really important to note, to make sure that you do get some of these blanking plates, because there's always one terminal block that's gonna have like its contacts, you know, its internal contacts, metal contacts exposed, because there's no terminal block to the left of it. So really important that you install these, because if someone's like servicing the panel, trying to get a cable or something, and it's live, they could easily get a shock from those exposed metal contacts and internals of the terminal block. Another really important thing to note, so this is something that I discovered, is, and it set me back a little bit, so I'm saving you going through the same issue that I had. But one panel that I did, let me see, yeah, one panel that I did back in the day, here we go, is a better photo. It was laid out differently to this one for a different project. We were using these metal cased PSUs, and we had some terminal blocks right up, you know, where this other PSU is, right up against this metal plate. And I wasn't using one of those blanking plates that I just showed you on the terminal blocks. And obviously the internals were shorting out against this metal casing, and we were having to fault find it for like half an hour, whatever it was. And yeah, we finally realized that it was that shorting out. So little tip there is, yeah, just use those blanking plates for safety, but not only safety, for making your lives easier, reducing any potential faults that might creep in. All right. So yeah, just getting all the terminal blocks in place from our terminal block layout. I'd always recommend designing your terminal blocks prior, rather than kind of like trying to do it on the fly whilst you're wiring it. It's just so much easier to put your mental energy in like when you're in the design phase in a computer office environment where you're kind of locked in, you're thinking about all of this stuff rather than trying to like think it through when you get to the panel build phase. It's just so much nicer when you get to this panel build phase just to go full steam ahead with all the wiring. Yes, you might have to change the odd thing here and there, but you've already thought it through and you can just get on with wiring it. So this is going in place, referencing the terminal block layouts that you should get access to in the resources. So yeah, just making sure they're all in place. You can see close up of the fused terminal blocks. Not put the fuses in yet. These are really nice from Wago or Vargo. So you can see when it's got an LED. So if everything's okay and the fuse hasn't blown, that LED will be lit. Because we want to make sure that we're fusing, as you can see here, 24 volt DC power going out into the field as well. It's not just for 230 volt AC, it's also DC. We want to protect those cables. Same thing again, fuse terminal blocks there. These are really cool terminal blocks from Wiedmuller. I'll explain them and how they work a bit later on in future modules and trainings, but really cool, especially for doing these types of home automation panels. And then you can see here from Vargo, we've also got our RJ45 or Ethernet straight through connectors that are going to go off to the mini server and the audio server. So it just means we don't, everything is contained within a panel. All we need to do is just have cables coming in, and that's it. Here we don't need to worry about extra faff, extra wiring in the panel. It's all done basically. So it just makes it so much easier to do things in the workshop and off-site than when it comes to being on site doing commissioning. And it's just, it's less stress, it's easier, you're in a controlled environment, there's no distractions, there's no other contractors, there's no mess, dirt. It's just, you can lock in when you're in the workshop and just do things far easier. Site time is always way more expensive, more costly. So do make your lives as easy as possible off-site. Do as much as you can off-site. Another image. Okay, the alarm has gone off in the office block that I'm working in. Very annoying, but let's continue. So here you can see I'm just using a torque wrench or torque screwdriver set to the right torque setting for these RCBOs, and now I'm just tightening them up, or tightening up the buzz bar to that right torque setting for the RCBOs. And then you can see here, really like these covers. We're leaving extra connection points there if we ever want to expand and add additional RCBOs later on. But for now, we obviously just want to, these are live conductors. We want to make sure that they're safe and protected. As you can see, what I was talking about earlier, this is the earth block that we're going to be using that's mounted to the enclosure, the metal enclosure, because we want the enclosure to be earthed, and that was moved from the bottom up to the top. And then same thing with the neutral bar. The only difference is you can see that these are raised up off the back plate or back of the enclosure using these nylon spacers, because we obviously don't want the earth and the neutral to be sort of shorting out together. You'll see later on that I do add an additional piece of trunking along here for all of the, because there's going to be cables coming out the top of the PSUs and then going into the fused terminal blocks. So it's a little bit annoying that you don't get that, but it's what it is. There's the Brother label machine, really helpful, really good piece of kit. That is the label size that I'm using, anyone that's interested. Tweezers, so I was using tweezers to attach those labels. Again, makes life so much easier. And then you can see here the sort of standard font size and layout to the labels that I'm using for the PSUs. You know, like PSU, power supply unit 1, and then it's feeding the LED strip. PSU 3 feeding the power for the tree lighting, etc., etc. And you can see, really important here is, as you can see, it's firstly just keep everything consistent. So same font size, same label sizing, same spacing, and they're all positioned along, you know, this datum point here, and it's in a space that doesn't have loads of details and information. That's sometimes a little bit difficult, but what you don't want to be doing is covering up some helpful information, you know, like the part number, like the model number, like input output voltage. This is all really helpful information, just generally speaking, but also for someone that's on site. PSUs, just so you're aware, PSUs, electronic power supply units, are usually the first thing to go in these types of projects, in any type of controls projects, whether it's, you know, smart home, commercial BMS, industrial controls. It's always them to go first. So help out the guy who's going to be servicing this machine later on. It may well be you. Like, you just want to, if you can see that the power supply isn't working, it's gone down, people just want to see, okay, it's a, you know, it's a Meanwell, it's an NDR 240/24, and then it's outputting a total of 10 amps, right? And they can just quickly go and find that and replace it, rather than having all relevant information covered up by a label that they then have to, you know, remove. And it's just think about the person after you, if there is going to be another person after you. It's all very well and easy doing things in a controlled environment, in an office, in a workshop. It's far harder when you're on site. So have a bit of consideration for the commissioning engineers, the service maintenance engineers, the installation guys. And there we go. It's all labeled, ready to go. You can see here, same type of thing for the modules and the extensions. So AS audio server, SE stereo extension 1, 2, 3, etc. And you'll see later on again in the training why I'm doing this, and it's more so because it ties in with the programming and the configuration, and it just makes things on site a lot easier, you know, when doing the commissioning. So that's why they're labeled like that. And then with the RCBOs, you can see RCBO 1, that is feeding dimmer extension DE1, dimmer extension 2, RE1, relay extension 1, RCBO 2, power supply 1, power supply 2, etc., etc. So you can see what I'm doing there with the labeling of the RCBOs. Again, just making life as easy as possible for when I get to site and do the commissioning, and for the customer, and for any engineers, you know, looking after this project after me. And I think that is pretty much it. And we are all ready to go on the wiring. Happy days. Yeah, now it's on to the exciting stuff.
Now, I just want to jump in here quickly. The sections that you're watching in this video are just some of the panel build clips taken from the full 15-hour training course called Smart Home Specialist, where I cover absolutely everything to do with this project. The specifying, the design, the documentation, the panel builds, the testing, the programming, and the on-site commissioning. And I also completely pull back the curtain on this project, sharing all of the financials, the numbers, plus all of the documentation and resources you'll see me referencing throughout this video. Oh, and the complete programming files as well. Now, I don't want you to look into this right now. Please just carry on enjoying and learning from this video here on YouTube, but I just wanted to make sure that you were aware of it. So if you are curious to learn more about how to deliver professional, profitable smart home projects, or you just want to learn more about Loxone in general, there's a link in the description that you can visit when you're ready.
Okay guys, so now on to the wiring, and obviously this is going to be broken up into lots of different stages, but the first stage that we're going to focus on is the wiring of the neutrals from the RCBOs to the neutral bar, and then the main supply neutral feeding that neutral bar.
Okay, on to the next one. So, as you can see, pretty straightforward. I'm going to pause it because I'm going to run out of time, but we're just wiring in the neutrals, the neutral tails from the RCBOs. And what you want to do, well, I'll explain this in the images in a minute, but like the close RCBO 1, put that, I'm doing it, yeah, put that on the like furthest left, like the furthest left RCBO 1, put it on the furthest left neutral point. And then like work your way across. I'll explain it in a second, but hopefully you know what I mean. And on the far right, we've just got the main neutral feed or supply, or however you want to refer to it. So yeah, pretty straightforward, this video. Let me pull up the images. Just going back a second. So as you can see, so I can actually got, you know, not only the cables on the top of the PSUs, we also need space for those RCBO neutral tails. So yeah, I've added in this trunking, which I had in stock, which isn't big enough. It isn't big enough, but I didn't have anything better, and I think the next one up that I had was too high. So yeah, that was the best I had, and then I just used some double-sided Gorilla sticky tape to hold it down. But yeah, this is obviously how they start off, these RCBOs. And yeah, that's a pretty good image. Oh no, so this is what I mean. So you might, I wired them like this to start with, and then I was like, what about if we do add some RCBOs later on? Again, I'm just always trying to think one step ahead or a few steps ahead. You know, in this eventuality, if someone added an RCBO, then they'd have to wire in the neutral tail into this here, and then it just doesn't make logical sense, does it? So I thought about that after I'd already wired them in, and I was like, nah, I need to redo that. So yeah, I redid them. A little bit annoying, but now RCBO 1, this one here, that neutral tail goes here, yeah, and then RCBO 2, that tail goes here, and so on and so forth. And if we do add additional RCBOs, then it just continues in a logical manner from where we left off, you know? So yeah, that's pretty much it for that video.
Okay, now on to the second stage of the wiring, and that is the live and neutral feeds from the RCBOs to the PSUs or power supplies.
Okay, on to the next video. Again, pretty straightforward stuff, but I'm wiring out of the RCBOs, and we're now providing those feeds, the live feeds, and the neutrals to the PSUs. So what I want to do, why I'm doing it this way, like you can see I've got all these long tails. What I'm doing is I'm basically measuring. I think what I do is I measure the furthest point on the RCBOs to the furthest point on the PSUs. And yes, you're going to have some additional pause it, additional cable left over. But what I do is I'll do like a measurement from here. That's the furthest RCBO, and then measure all the way around to the furthest PSU. If it's this one, yeah, this one. And then what I'll do is I'll just like, well, so that's this long. I will cut one, and then I will just cut multiple lives, multiple neutrals. And then what I can do is I don't have to think too much like, oh, this length goes here, this length goes there. They're all the same length. I can just quickly screw them all in here, and then I can dress them in together neatly. Because if you're trying to dress it in one at a time, it looks crap. And this way I can just keep them all together, swoop them in, and then I can just identify and cut them to length as they get, you know, as I put them in place. Now, yeah, you could argue that that's going to be quite a lot of waste, you know, from the closest RCBO, this one here, you know, to this closest PSU. It's only going from here to there. You know, you have a lot of excess. Sorry, we're not even going to the top, we're going to the bottom here. So I might have done things slightly different here, but yeah, if I have a bit of excess cut off, you know, I don't care. I don't care. It makes my life so much easier. It's only cable at the end of the day. That's how I do it. If it's a ridiculous amount of excess, I do think about it, but generally speaking, I don't bother. I just go for it. But yeah, you can see now I'm dressing it all in. I'm tie wrapping them together just to keep them together and looking nice. It's a bit of a, you can see it's quite tight here. It's a bit awkward to do. There's not much space, and these cables sit over the top of the trunking, so you kind of need to swoop them round down into the bottom of the trunking and then back out to the primary side of the PSU. So it is a little bit awkward to do these. This is probably the most awkward part of the wiring, just where it's so tight, and yeah, well, as I just explained. But yeah, this is what I'm doing to keep it all tidy. As you see there, I quickly was using my continuity tester just to double check what cable's what, because they're not labelled and they're all the same length. So it's hard to differentiate unless you use continuity tester to just double check. Let's fast forward a little bit. And then, yeah, just coming out the bottom of the trunking, swooping up and connecting. And that's the last one going in, as you can see. Okay, that's pretty much it. Let me just pull up the images. There's not really much to add, but yeah, it basically just looks exactly like I've just shown you on the video. Yeah, as you can see, quite messy, but like we've done the best job that we can. And you can see what I'm doing is I'm sweeping out and then under, so like this one's easiest to follow. I'm sweeping out under, they're tie wrapped together, and then we're going into the finger trunking, and then out to where they need to go, and then out and up to the PSU. Okay, I think that's it for this video.
Okay guys, so now on to the third stage of the wiring, and we're going to continue with the PSUs, and now we're going to focus on the secondary side of the PSUs. So firstly, we're going to wire the positive side to their respective fuses. We're going to common up all the 0 volts, and we're also going to add an earth to each of the PSUs that require it.
Okay, on to the next video. So what am I doing here? Yeah, so as I mentioned earlier on, I added some distribution terminals for the 24 volt DC, positive and negative. So that's what I just did there with those terminal blocks. And what you can see here is I'm just adding those earths. And I'm always conscious of, trying to not overuse these and overuse cable if I can help it. So I looped a couple of those earth cables there. As you can see, these oranges, they're going to be for the 24 volt positive. So they're cut to length already. Again, similar to what I mentioned earlier, like I cut them to length, then I strip them, then I put a terminal block, a ferrule, sorry, on each end, and then I, as you can see, kind of get them into position. We got purple, I think, is that purple, representing the 12 volt DC. And as I mentioned, the orange is representing 24 volt DC. So we're putting all of those into the fuses or fuse terminal blocks, same with those bottom power supplies as well. So those are all the lives positives done now. Now we're doing the same things with the negatives or the 0 volts of those 24 volt power supplies. We'll do the same with the 24 volt power supplies and 12 volt power supplies. And you can see that we're commoning, is that a word? All of those 0 volts to this point down here, these terminal blocks here, and I'll show you on the images in a minute. And we got this distribution or buzz bar connecting all of them. So let's have a look at the images and see what we got here. Yeah, so just a better view of what I've just explained. You can see here this trunking. There's now no more to go into this trunking, but you can see it's pretty busy. Ideally we don't want that. We want it to be a bit more free, a bit more like this. But what can you do? But yeah, we got into the fuse blocks, and this is that distribution of the 0 volts. So yeah, all the 24 volt negatives are going there. All the single 12 volt DC negative or 0 volts is going there. And what we could also do, and it's recommended, is to actually earth this. I'm not sure if I do that later on. I'm not doing it here, but it's one of those things that I would do at the end. But you could connect all the 0 volts to earth as well, just so they're all at the same potential. The only time that you might not want to do that is probably on an industrial site that has what's known as like a dirty earth. There's a lot of noise and interference connected to that earth point, and if you've got sensitive analog signals or any type of like extra low voltage sensitive signals, you could get false readings and interference if you do that. But this is going into a residential property. That's absolutely fine in this case, and yeah, would actually be good practice. And yeah, that's pretty much it. Yeah, pretty self-explanatory, pretty simple video, but that was the next step.
Okay guys, so the fourth stage, for me at least, is now to go back to the RCBOs and finish off the 230 volt supply to the relay extension and dimmer extension.
Okay, I will start off just by explaining things a little bit. So what we're doing here is we're going from RCBO 1, and by the way, this is the templates, the documentation, the terminal block layout for the project, which is all in the resources. But RCBO 1, you can see that is supplying dimmer extension. Let's zoom in a little bit. Dimmer extension 1, 2, dimmer extension 1 and 2, and then they got 4 channels. So channel 1, 2, 3, 4, 1, 2, 3, 4. And then also the same RCBO is supplying the relay extension 1 all the way up to R6. so relay 6, and then RCBO 3 is feeding same relay extension but going from relay 7 up to relay 14, and you can see what are they supplying. So for example, we've got a dimmed living room circuit, living room feature light circuit, etc, 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 and then the relays, you can see they're doing various things, outside, under balcony lights, ensuite mirror lights, etc, etc. So that is what we're about to wire now, but obviously inside the panel, but coming from RCBO 1, RCBO 3 to the feeds of these dimmer extensions and relay extensions. So let me show you what that looks like in the video, and then we'll come back to the images. So yeah, we're taking a feed from up here, RCBO 1 or 3, and we're doing the dimmer extension first. So we're taking that neutral. This is the thing with the the dimmer extensions. The neutral also goes into the module as well. The feed goes into the module and it also comes out. So it's important to do that. So you can see I'm buzzing that neutral feed from the RCBO. That's exactly what I've done here across all of those feeds. And then I'm doing exactly the same, the feed from that RCBO 1 to the input side of the relay extension, or sorry, dimmer extension. Let me just see if I can pull something up, just a sec. Yeah, so Google Loxone dimmer extension wiring, and I wonder if we can. Yeah, so what you can see we're doing here is that's the live and the neutral from the RCBO. And so what we're wiring here is the feed, L, and the live feed and the neutral feed, N. And then you can see I'm just looping in and out, and then later on what you'll see is the neutral going out, and in this case it's going straight to a light, which is fine. That's a light out in the field, but we'll be wiring it to some terminal blocks for then the cables going to that light in this example to then go into the terminal blocks. So yeah, hopefully that explains what we're doing here. So yeah, those double ferrules is where I'm looping in, looping out. Obviously the last one here, we're not looping on to anything else. But that is pretty much the dimmer extensions done. And just sorting that out, making it neater. Again, so there's less cable filling up the trunking. And you can see, look, I've actually, when I added in the feed cables from the RCBOs, you can see that I labeled it just so I don't have to do a continuity test. So yeah, now onto the relay extension. Let me do the same thing for the relay extension. Just a sec. Yeah, so what we're doing here, ignore like the push button up here, just look at this here. So although this is the mini server, it's the same principles for the relay extension. So what I'm doing here is L1, that is the feed from the RCBO, and we're feeding in to one side of the relay, and then the second side of the relay later on, when we continue the wiring, we're going to be wiring out. And this is like the switched live that will end up going to one of those things that we mentioned, outside lighting. But obviously we're going to be going through a terminal block here. And this neutral supply, again, we're going to be going through a terminal block in the panel, but that neutral supply is just, you'll see later on, but we're just taking that neutral straight from the RCBO down to the terminal block, and then we're distributing with a little buzz bar that neutral across all of those terminals here. So just one, there'd be two possibly, no, B1 neutral and then bust across here. But yeah, that's what we're doing wiring wise for the relay extension at the moment. So yeah, feed coming in, and then we're doubling up, double ferrule, and then we're feeding the next relay. Okay, and the next relay, and the next relay. So this is, again, just like the feed coming from that RCBO being distributed across the feed side of these relays. Then we can program this relay extension to switch based on, you know, what we do in the programming, based on the application, based on what the spec is. We'll just switch automatically, you know, on or off. For example, with lighting outside, we could have it on a time schedule. So, or when it gets to dusk, then switch on this outside light. So it will go from that constant 24 volt feed. It will then switch that relay and then send the power out on this cable, you know, down to the terminal block, and then through the terminal block, through the cables out in the field, off to the light, and then back on the neutral to that terminal block, and then the neutral goes back to that RCBO. Hopefully that makes sense. What I could do is I could do a quick whiteboard for you. So let's just say this is the RCBO up here, okay, and then we've got this is the feed side of the relay. Actually, let's not confuse things. So this is a relay, you know, with those red connections, and then we got the live from the RCBO goes in there, and then, you know, let's say we got, this is relay 2. What we're doing is we're then distributing out to the next one. So in this example, let's say we've got it programmed for the light to come on outside when dusk hits. So the sun goes down, and we've also got cables coming out. This is the switch side of the relay going to a terminal block. I won't draw it for this other one, but that's the switch live. And then it's going out to the light in the field. And then with the neutral, we're coming out of the RCBO, and we're just going straight over to the same terminal block, and then that's going over here. Yeah, so feed, live feed, and now this is the internals now of this relay module, and let's just draw like a simple relay switch. So we got that feed, constant 230 volt feed here, and then as soon as dusk is detected through the clever system that we're using, that then closes. All right, so that 230 volt AC then goes through here, out on the switch side of the relay, through this cable, through this cable, through this cable. These are terminal blocks, by the way, terminal blocks. Through the terminal block, out into the garden or wherever, brings that light on, and then obviously we got the neutral that is just constant, goes back on the neutral to the terminal blocks, back to the RCBO. So hopefully that explains what is going on here. So yeah, let's continue. Oh, that's basically the end of the wiring. Let's have a look at some of the images. Basically what I've just explained. But yeah, from one of these RCBOs up here, coming down, and you can see I'm actually not wiring the neutrals at the moment. I'm just leaving the tails there. Again, just to make things neat later on. Once everything's ready to go into the terminal blocks, like I usually use the wire the terminal blocks last. I want to just make sure that everything's swooping nicely. There's not things coming from this direction and that direction and just getting all messy. So I'm leaving those unterminated for the time being. But I've done, as you can see, the supplies for the dimmers. So the supply live in, and you know the neutral feed in, swooping, 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 and then going over here, swooping over here, and then we're finishing off here. And then later on you'll see the switch side of the dimmer going out down here to these terminal blocks, and it's a similar thing with the neutral, with the relay extension. We got the feed coming in, going in, swooping, 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 and then I think we got another. Yeah, there's 2 RCBOs being used on the relay extension. You can see there's the end of the line of one because it's only a single ferrule, and end of the line for the other. But yeah, that is that for that video.
Just a quick reminder, guys, those design resources like the terminal block layout and images that you've just saw me referencing, they are not something that I've just thrown together for this video. They are taken straight out of my Smart Home Specialist training program, the same 15-hour course. The panel build sections that you're looking at now are taken from. And in there, amongst many other things, you'll get the complete design vault, all of the documentation, like the ones that you've just seen, the CAD drawings, everything I use on real world projects, just like this one. Now look, I don't want to take you away from this video, so let's crack on with the panel build. But if you ever do find yourself wanting the actual resources and not just watching me reference them, then there's a link in the description waiting for you whenever you're ready to dig into it.
Okay guys, on to the next stage of wiring, and we're going to go back to our fuses, which are currently being supplied by our power supplies, and now we're going to wire from the other side of the fuse to various extensions and modules within our panel. And in this video we're going to focus on the 24 volt supply to the RGBW extensions for the LED strip power to feed our audio server and stereo extensions for the audio obviously, and then of course the power to our mini server, our extensions like the relay extension, dimmer extension, tree extensions. And then in the next video we're going to come back and look at the supplies to our tree devices, and then in the next video it's slightly different wiring for our tree lighting and our 12 volt Winkhouse door lock supply. So we're going to come back to that, and at the moment we're not going to focus on the tree lighting 24 volt supply. The tree supplies for the peripherals like the motion sensors, switches, and we're not going to focus on the 12 volt supply to the Winkhouse lock. We're going to cover that in the next video because it's wired slightly differently.
Okay, so as you can see here, the orange on all these modules, like the orange, white, you can't see it on these are older style modules, but these green bits here, the orange connectors here, that's ultimately what we're wiring in. Oh, also here as well, so the tree extensions to power the tree extensions, that is what we're wiring in this video. So yeah, we're taking, obviously we've already wired into one side of the fuse terminal blocks. Now we're coming out the other side, and we're looping in, out, in, out, in, out, from what I remember, and that's powering the stereo. No, sorry, that's powering the RGBW LED strip that's going across the property, and then we're also taking our 0 volts as well directly back to the PSU that we're using, rather than going through the terminal block distribution here. So yeah, just dressing in the cable, and then that's this next one that I'm doing here is for the audio server and the stereo extensions. So again, from what I remember and what I can see here, we're looping in, so out from the first one to the next one to the next one to the next one. I'd have to check my schedule. I'd have to check the schedule to remember exactly which power supply is powering which audio modules. But now what you can see is the twisted orange and white that is solid core, it's not stranded. That's what we're using for, as you can see, the power to the extensions. So I'll pause it in a second. You'll be able to see from the images. But yeah, so similar thing, we're coming from this side of the fused terminal blocks and we're running over here to the first extension, the mini server, and then out there, out of that to here, across here to the relay extension, and then we're going on to the tree extensions here as well. And I think from memory that's coming from this power supply or this one or this one. What we want to do is we don't want everything coming off the same power supply, because if so what I mean by everything is all of the power to the extensions, the control modules, all of the power to the motion sensors, the switches out in the field, all the power to the lighting devices like the LED strip, the RCBO spots. Like if we've got like just one power supply for all of these things and the power supply goes down, then we've lost everything. So we want some level of segregation and redundancy. So like if, for example, the power supply to some of the lighting, like the LED strip, goes down, that power supply fails, because power supplies do fail. It's probably the most common thing to go down in a control system. We don't want that taking out, for example, the control and the monitoring of everything else within the system. So we've got like literally the one power supply goes down and then everything in this house is uncontrollable. Now, obviously, if I won't go down that route, but yeah, hopefully you get what I mean by that. So let's have a look at the images. So yeah, that's not the best image actually, but you can see here, this is the power for the RCBO, so the red, green, white, blue LED strip out in the field, like going around coving, going under cupboards in the kitchen, that kind of thing. So we're looping in, out, etc. And you can see this one's an older style RCBO controller, but same function. And so that was those ones with the thicker cable. They need to be thicker cable because it's, I think we're using the 10 amp power supply, so it's carrying more current. But then we're using this thinner twisted cable, the white and the orange, and that's being used for like the modules, the extensions. So we're going in, out, and this is solid core cable. It's really nice using with these connectors, because you just push it in. You don't have to screw up the terminals, as you can see on these ones. Can get a little bit fiddly, but if you go in once and then loop out once, then it's fine. But you can see coming in here, providing 24 volt DC supply from I think it's this. You can just about make out Loxone extensions. So that's the power supply for all of this twisted pair power that I'm talking about now. So it goes in here, power for the mini server, out, power for the dimmer extension 1, out, dimmer extension 2, power for the relay extension, and then we've already got power for the RCBO controllers. Then we're going out along here, power for the tree the tree devices or the tree extensions. Again, similar to what I mentioned about redundancy and segregation, we want a different tree. We want a different tree extension based on, well, you got to consider the amount of devices that you have. I think it's limited, if I remember correctly, to 50 devices. But the other thing is, like, so you got maybe a tree extension controlling the lighting. Maybe you've got a tree extension controlling or providing comms to the peripherals, like the motion sensors, the valve actuators, the touch switches. Maybe you've got one that you're using specifically for tree devices outside. So if you've got water ingress or there's damage to, a device outside, again, it's not knocking out all the other tree devices on that network. So again, it's yes, there's more hardware, more controllers, but in terms of the system design, it makes sense. You'd rather pay a little bit extra for some extra controllers than, say you've got a outside weather station and water gets into it and then shorts out the tree comms, and then that takes out all of the tree comms communications across the whole property or the whole building. Like, it will just, in this case, how I've designed it, it will just take out the rest of the devices that are outside. It won't affect everything inside. So that's why it's so important to think a couple of steps ahead when you're doing the design and the specification, about these things, the realities of, the realities of things being on site, what happens in the real world. And then I think that is it in terms of the power distribution. Yeah. So that is it for this video.
Okay guys, so as I mentioned on the previous video, we're now coming back to have a look at the remaining outbound fuses that are going to the tree peripherals and the tree lighting.
Okay, right. There's not really much to look at here. As you can see, I'm connecting the cables here going out to the field along here and down to the terminal blocks, ready for later on when I'm going to be dressing in all the cables for these terminal blocks. So as you can see, I've labeled them here, and we're also, so yeah, those are the positives from here. What PSU are they coming from? What are they supplying out in the field in terms of the label? And the path that they're taking is from the other side of the fuse terminal blocks down here, and they're just waiting here for the positives, and then for the negatives or the 0 volts, they're either coming directly from the PSU, because I think there's double, I'll have a look at the images in a minute, I think there's double points for negatives. So they're either coming off those power supplies directly, or they're coming from this distribution block here. So let's have a look at the images. There's, again, not really much to look at here, but you can see, there we go, this is a better one. I think these are 10 amp fuses, because most of these, well, all of them, if they're 10 amps, they're coming from the 10 amp power supplies. So we just wired in from the other side here, and then we're wiring down to, well, in this case, we're wiring down the few cables that we're talking about down here, ready to be dressed in. And as I said, they've been labeled. So let's just have a look at the documentation for the tree devices, the tree layout. Let's just look at the ground floor to start with, or you'll get a good picture of what's going on here. So what we've got is this is the tree layout. So this is power. This is going to be well, we can see here on the key. So this is the tree layout, the tree network, the tree power for our spots, our RGBW spots, our touch pure. So if you're not familiar with Loxone, so yeah, RGBW, red, green, blue, white spots, so color changing spotlight. We got our touch switch here, so a switch that can control lighting, blinds, audio. It also has a temperature sensor and a humidity sensor built in, so we can have simple zoned heating, cooling control. We've got presence sensors. We've got tree to air bridge. That basically enables us to extend our wireless coverage. Nano 2 relay trees, so they're basically just relays, so we can control multiple things. With these, in this project, we're using them to control blinds and Velux windows, open and closed, if I remember. Ceiling light, so that's again just a ceiling light. Touch flex, that does multiple things. Yeah, I'll leave it there, but these are all the components that are on the tree network. Let's just take the living room, for example. So let's zoom in a little bit here. So you can see what I've done is I've split them, and this would make sense if you looked at the tree schedule that I've also created, which we'll have a look at in a second. But I put it down to zones, and what we got in this zone 1 is I'll have to remind myself what these abbreviations mean, but we've got our feed from the panel. So what's going on here is this is a feed all the way from the panel. So we've got the panel up here, wherever it's situated, and then we got the first leg coming in here. And then this is the great thing about Tree, because it's digital, you can wire these things however you like, as long as there's not a closed loop. And I'll explain, as you'll see, there is actually a loop. We loop back round and go back to the panel in a second, but I'll explain why we do that. But we're coming from the panel, we're providing communication, tree communication to these devices, but also power. And some of that power from those 10 amp power supplies, or a lot of that power, is going to be for lighting. So for example, let's zoom in a little bit further. So we're looking at our key. It's difficult to see on these PDFs. We can only zoom in so far because we're accessing them within the Google Drive. But if you downloaded these, you could obviously zoom in much farther. And if you want to access the CAD files, we've also got those as well. So you can use these templates, modify them, and but also go in even closer and see what's going on here. But yeah, we got spots. So these are all the spots. We got a motion sensor in the middle here. We got our switch over here. We got some extensions like the tree to air bridge. Oh no, sorry, this is controlling the blind. Sorry, that is our tree to air bridge to extend the wireless network. I think we got another motion sensor here. But you can see it's going around in a kind of loop, but then we're spurring off. But this is the main loop here. We're spurring off here, controlling some blind controllers. So the Nano 2 relay tree, I think they are. But then you can see we're moving back up here, and then we're going back to the panel. So the reason I do this is we only need one leg connected at the panel, because if we connect both legs, then we just got a loop, and that's going to just cause communication problems, and it might even cause like shorting out on the power. So on the tree com side, well, both sides, the power and the tree comms part of the cable, we just put that back to the panel and we don't terminate it. That is there as a spare cable, really, more than anything. So let's say that we did have a break in this cable during the installation and we couldn't get to this first spot. Well, that's fine. We can just connect this cable, this side of the cable, at the panel, because this side's redundant, you know, there's a break in the cable, and we can pick everything up and control everything and monitor everything on this leg. So it's just there as a bit of redundancy more than anything. But yeah, that is kind of what we're doing with all of the tree zones within this project. So that's obviously the living room zone, we've got the kitchen dining zone, and it's the same thing. We're coming from the panel, we're looping into all the devices, the spots and the switches and the motion sensors, and then we're going back to the panel for an additional leg that most likely will be redundant, but it's there just as a precaution if anything goes wrong with the wiring. So yeah, that's kind of what we're doing with those images. So yeah, a lot of these cables here, they're going out to those terminal blocks here, you know, the positive 24 volt DC and the negative, or the 0 volts, and then that's what's going out to what I just showed you here. On the power side, the way we do the tree comms is slightly different. I mean, it's the same cable ultimately, but the wiring back at the panel is different, and we'll look at that a bit later on. Okay, so that's it for that video.
Okay guys, quick section now just showing the wiring of the Winkhouse door lock.
Okay, on to the next video. This shouldn't be a long one. This is just the Winkhouse door lock control from the 12 volt power supply here. As you can see, we're using a purple cable going into the fused terminal blocks, and then here, before I move the camera, you can see the other side is then going down here, and then as we move the camera, it's feeding in to one side of a relay on the Loxone mini server, and then the other side is going over to our terminal blocks. So let me show you what that looks like. So yeah, as I just mentioned, purple 12 volts in through the 2 amp fuse and then out, and that's then going to the mini server on one side of the relay. Okay, so that's the feed, the constant 12 volt DC feed, and then when we program that relay to close or open, depending on the configuration of the lock, it then will send a signal or the 12 volts down this other cable, which will then go to the terminal blocks. As you can see, there's the purple cable, and then out to the field. So just to give you where is it? Yeah, the tech manual here. So this is the tech manual for the Winkhouse door lock. We're using it in this configuration, and like we got to imagine these as the terminal blocks. So you can see that the Winkhouse lock needs a constant 12 volt DC supply, you know, the positive and the negative. And we kind of think about these as the terminal blocks, because obviously this cable here is fixed to the lock, so we're going to have some like Vargos or like terminal blocks out in the field. But like one step past this, you know, like we've got some terminal blocks going in here, which is providing the positive, negative 12 volt DC. But then what we've just done here, we've got to imagine that this is the relay from the mini server. These are our purple cables, so we're getting that 12 volt constant feed here, and then once we trigger the lock to open or close, or however you got it configured, this then closes and sends that 12 volts down out into the field, and then connecting to this green cable that is connected to the lock. And just to give you some context of how I do my schedules, so we're looking at this one here. So we got the Vargo, Wago numbers or terminal block numbers here. Panel name is Lox1 from the plant room to the front door lock. The room abbreviation is EN, just so when we're referencing our floor plans, our layouts, our cable schedule or cable layouts, this is our cable schedule. We got that there. Circuit number, yeah, so EN, so entrance hall, FDL, front door lock, that's our circuit number. And then a description of the circuit is a front door lock, Winkhouse. Our voltage, 12 volt DC. Control is switched. The cable that we're going to use is a Cat6A. And we can see then, what module is that connected to within the control panel. So it's a really mini server 1 relay. We're using a relay of that mini server because that mini server also has things like digital inputs as well. And then we can see that it's channel 5, so relay 5. What is it connected to in terms of the PSU? So the 12 volt PSU 7. And then what sort of fuse are we using? It's fuse 7 and it's a 2 amp fuse. So the 7th fuse along and it's 2 amps. So hopefully that makes sense, and that's it for this video. Okay, I didn't do an intro video for this one, but it's very simple. We are now wiring the Loxone link communication. So that is ultimately communication from the mini server. We're using the blue and white twisted pair here. Again, solid core, so we can just push it straight into these nice push connectors, or at least on the modules that have it. So we're going, it starts from the mini server, and then we're just daisy chaining across. I'll show you on the images in a sec. But yeah, mini server, dimmer extension, relay extension. Then we're going over to our tree extensions as well, and that's it, because everything else is controlled by tree turbo on the audio and tree for the RGBW tree extensions. And let me just show you these images, and then I'll go into a bit more detail about the link. So yeah, we start here, as you can see, just a twisted pair going in. And then we're going, we're doubling up here. So with these older connectors, it's actually not great trying to get 2 solid core cables connected nicely with that screw terminal connecting nicely down on the cables. So you've got to be a little bit careful there. Always check. So after you screw them down, especially when you've got like 2 cables or multiple cables in that terminal, but even if you just got 1, just always give it a pull. Make sure that the metal is crimped down onto the metal core of the cable, the copper core of the cable. And also you want to be wary when you strip it back, that you strip it back enough that it's not crimping down on the insulation, because then you'll have communication issues and you'll be racking your brains trying to find out, where is this issue? You're doing a link diagnostic in the software and you're like, where the hell is this coming from? So it pays to take your time to make sure that, you're doing things like stripping it back the right amount. And you don't want to strip it back too much where there's exposed, copper cables here, where then it's unlikely, but something could short, across there and there, a bit of cable if someone's modifying the panel, or a bit of swarf or debris or something. So as you can see, I've been very specific with the length I strip it back. I always test it. So I set my cable strippers, I strip it back, I put it in the terminal, and then I look at, is that enough? Is that too much? Is that too little? And if it's okay, great, I can do all the others. But always check it first time around. But anyway, off on a bit of a tangent there. But we're coming from the mini server into the dimmer extension, and then we're going out to the next dimmer extension, and then onto our tree devices. So in, out. So as you can see, it's nice and easy on these connectors because you just push them in and that's it. You might have to adjust the length of how much you're stripping back the insulation, compared to these ones. It might be that you're stripping it back too much and then there's copper exposed here. So again, just double check that. You can see there's no copper exposed. It's the perfect amount of copper going into these connectors. And then we're going on to our relay extension. And so what you've got to bear in mind on this project is we've got Lox1 panel, okay, and then we've also got Lox2 panel. Lox2 panel is situated in the garage, and we're actually extending that Lox link through a cat cable, from Lox panel 1 to Lox panel 2. So you're not seeing the last. Let me go back. The last. So this is kind of the last point that we wire the link into in terms of modules in Lox1. But then these tails go off to the terminal blocks because we're then continuing that link connection over to Lox2. So as you can see here, that Loxone link is coming in here and then being distributed into these devices as well. And then so it goes in here, the Modbus extension, the one wire extension, the relay module, and here you can see that is the final point on the line where you are supposed to, or it's recommended, that you then have a 120 ohm resistor on the final extension. So like what we've got here is power supply. We can kind of like disregard that. I'll come back to explaining why that is in this diagram in a second. But you've ultimately got the link, the Loxone link. Let's zoom in a little bit. Loxone link, let's just say that this is Lox1 panel 1. So starting here, extensions. Then let's just say we've got some terminal blocks here at the bottom of Lox1, and then this is a cat cable out in the field, and then we've got some terminal blocks here in the second panel in the garage. We're coming in, we're continuing that Loxone link to the various extensions because we haven't got a mini server in this panel. Like if we were using a 2 mini server setup, then we wouldn't have to do this. But because we've got one mini server, one link output and communications, this is why we're doing that. And then at the final extension, we're putting that 120 ohm resistor. It's even though that's what's recommended, sometimes you don't have to use a 120 ohm resistor. I can't remember exactly what I found because it's been a while. But what I found sometimes is like there's problems when you do a link diagnostic in the software. There's sometimes problems and bad communication on the Loxone link, and you check all your wiring, it's absolutely fine. When you're pre-commissioning everything before it goes on site, in a controlled environment, everything's fine, you've checked everything. There's no other variables in terms of wiring in the field and devices out in the field. It's controlled. And you remove this 120 ohm resistor, and then the Lox link, the communication is then all green and there's no problem. So it's a bit hit and miss as to whether it's a good thing to use that 120 ohm resistor or not. It's recommended by Loxone, but the reality is that it doesn't always serve the project. Just going back to the power supplies, the reason that they're in here is just to show, like, if you've got power supplies across different panels, of which we don't in this panel, but in the other panel, Lox 1, we got multiple power supplies. What this is showing us is we want to make sure that we are commoning all of the 0 volts or ground across all power supplies, because those power supplies, all power supplies, let's just say that, all power supplies, because you can see that this also feeds each of these extensions as well, along with the link. And what can happen is if you don't common all of the power going to these extensions, without getting too technical, it can sometimes cause issues on the link where there's a potential difference, and the potential difference can affect, being the fact that they're not commoned, the power across all these extensions isn't commoned. The potential difference, if there's issues, can then go on the Loxone link, and that's obviously the communication to all of your extensions and controllers. That can then cause issues, and where you're not getting the communication that you need from the mini server to the extensions to control things out in the field or whatever else. So yeah, that's why you always common the 0 volts of all of your power supplies, to prevent things like that happening. All right, so that is it for this video. Bit longer than I thought it would be, but hopefully you've learned a few things from the Loxone link.
Okay guys, so now on to the tree wiring, and this is made up of 3 different sections. So the first section is the tree comms from the mini server to the RGBW extensions for the LED strip. Second section is the tree comms from the tree extensions out to the different devices in the field via the terminal blocks. And then finally the third section is tree turbo, which is the tree comms from the audio server to the stereo extensions. And this is a different type of tree communication, so it's not to be confused with the regular tree communication.
Okay, on to the next video. So yeah, with tree, it's very much about redundancy in my mind. So the first one that I'm doing here, so the mini server has a tree output where we can connect 50 devices. So I'm thinking, I'll pause it quickly. So in terms of the design, I know that I've got 4 RGBW tree controllers, and then the output side haven't been wired yet, but that's then going off to LED strip out in the field. So I'm like, well, let's use this tree output to control these devices here. So that output from the mini server is just keeping things in the panel, controlling the RGBW controllers. Then we've got 4 other tree extensions, which I'm going to be using for things out in the field. And then we've got our audio server, or the audio server that provides tree turbo, so it's different to regular tree. And again, that's just going to stay in the panel and go from the audio server to the stereo extensions. So there's logic here, but we're also, and I'll talk about redundancy in a second, but we've also got like redundancy. We're spreading certainly across these 4 extensions here that are going out in the field. We don't want all tree devices being on one extension. We want to spread the load, and I'll explain in more detail in a second. So we've done the first lot of tree. Now we're doing the tree turbo. So like starting here, looping out, and in and out, and in and out for our audio servers. Then this last part's nice and simple. We're just taking again, this is twisted white and green pair. And we're just going from these channels of the extensions. We got 2 channels per tree extension, and we're just putting in our cables, as you'll see in a second, off to the terminal blocks here, which we're then dressing a little bit later. You can see that I'm cutting them all to length because they're all going to be basically the same. They're all the same length, so I'll just take one measurement from here down to here, make sure there's enough slack on the end, and yeah, and then just strip back the ends and plug them in, and then dress them over here. And you can see from the labeling, just so I don't have to bail them out or do a continuity test later on, I'm already telling myself for when I dress these in here, so I know which cable goes where on these terminal blocks, which tree device it's coming from. So yeah, that's pretty much it there. So let's pull up some photos. Yeah, so this is the tree output. So I got 50 connections, I think it is, if I remember correctly. I have to check the documentation. 50 tree devices from the mini server. So let's keep that for the devices within the panel. So our RGBW tree drivers for our LED strips. So in here and out, in here and out, in here, and then that's it. And then what we've got is it's a similar thing with Tree Turbo for the audio. So we're starting here, and then that's just looping to these stereo extensions. So in, out, in, out, in, out, in, out, in, out, and then it ends there. And then those tree devices or tree extensions that are feeding devices out in the field, we've got 4 extensions. You can see those cables are just coming down here. Have I got a better image? Yeah, but anyway, as you can see, they're just dressed down here, and then they've got those labels on the end for when I dress them into the terminal blocks or terminate them at the terminal blocks. I think I took some extra photos here because it's really satisfying. That image, that's a lovely image, isn't it? Things are really starting to take shape now. All the different colours, all the wiring's looking nice and tidy. These like little swoops here are looking good. Similar sort of swoops here. It's harder to do with this type of cable. I think also here I've got some extra space. Forgot about this. I've got some extra channels that I could also use if the system was to expand later down the line. So again, it's just having some extra capacity, or let's say there's a short or something happens on this channel. Well, we got another channel, so we don't have to buy another extension. We can just say, this channel's blown. Okay, it's unlikely, but we can just move that over to this right channel. The left channel's gone. Let's just move all the control over to the right channel of this device. And then it's just a bit of reprogramming in the software, which is relatively straightforward. Yeah, so that's pretty much it. What I was going to show you here is on the tree schedule. I'm not going to go into all the details of this tree schedule, but what I wanted to point out to you is the redundancy and how we're splitting these modules or these extensions. So 4 tree extensions, and you can see TE1, 2, 3, 4. Okay, the labels. Then we go over here. We got our ground floor. So that's everything on our ground floor. We got our first floor. And then we got our heating devices. And then we got our control of our roof lights. And then we got everything outside. And these, as you'll see here, yeah, so module, tree extension 1. And then the channels, I won't get into the channels, but like what I wanted to point out is, yeah, tree extension 1 is feeding everything on the ground floor. Okay, tree extension 2, as we can see down here, is feeding everything on the first floor. Okay, so we've got some redundancy. If there's an issue with extension 1, something happens, least we're not losing comms and control and feedback for everything else. Like, it's only the ground floor that's been taken out. It's unlikely for this to happen, but it's, you know, precautionary measures that we're putting in place here. So tree extension 2 for the first floor, and then we've got everything in terms of heating. So valve actuators mostly are on tree extension 3. The nano relay trees, I think that was on the first floor, so we've paired that. I think this was something that was added in later. It was a modification to the designs, as that would have been done slightly differently. But here we can see the roof lights are being controlled, or the nano 2 relay trees that are controlling the roof lights are also on extension 2 because they're on the first floor. Those roof lights are in some of the bedrooms. And then outside, we've got a whole other tree extension 4. So if, you know, so take a step back. So we got like the front door NSC code touch, you know, the access point to get in the door and unlock the alarm. We've got a EV, electric vehicle wall charger. We've got an alarm siren. We've got a weather station. Like, these are, what would you say? There's a much higher likelihood that these devices outside in the field, well, in the field but outside, exposed to the elements, are at much higher risk of damage, water ingress, etc., than everything else. So it's much higher likelihood that it could be that water gets into one of these tree connections, let's say on the front door NFC code touch, and it starts corroding, it starts shorting out the tree terminals and the tree comms, and then that could ultimately take out the tree extension. And then let's say everything else, or a lot of other devices on tree extension 4, that would affect everything else. So we're just provisioning, and we're thinking a couple of steps ahead that, yeah, it makes sense to segregate out everything that's outside. So not only tree communications, what we're talking about here, but also power to these devices, have them on a different controller, a different power source, in case of what I'm just explaining happens, it doesn't take out the rest of the system. So this is why we're using, you know, this number of tree extensions. Okay, hopefully that makes sense. See you on the next one.
Hey guys, back again. That Loxone tree schedule that I was just referencing, that is from the full Smart Home Specialist course that this video is taken from. The full training course goes through the whole testing, pre-commissioning, programming, and on-site commissioning process, as well as the panel build that you're watching right now. Plus, you get all the finished config files and documentations to keep as well. Right, back to it. Links in the description explaining everything when you're ready for it.
Okay guys, on to the next stage now, and I'm going to go back to the 230 volt mains wiring, and now I'm going to wire from the relay extension and dimmer extensions to the terminal blocks for the 230 volt lighting.
Okay, let's continue. So as we can already see, the video's upside down, but it gives us a better shot of what's going on here, because I'd be in the way wiring it otherwise. So yeah, we got our feeds going into our dimmer extensions. We got our feeds. Now we're wiring the kind of the dimmed output. So the neutral and the live, dressing it into the trunking, and then putting it, yeah, as you can see, then now we're dressing them into the terminal blocks, you know, 1, 2, 3, 4, 5, 6, 7, 8, whatever it goes up to. So both the neutral and the dimmed live coming from the dimmer extension. Because we've already, our neutral from the RCBO is coming in on the feed side. So we're not taking that to the the terminal block. So let me just show you what we just done here. So we already had our feed going in and our neutral going in, and now what we've just done is, let's just imagine there's terminal blocks here. So we've wired from the output side, the dimmed output side for both the neutral and the live, into some terminal blocks here. And then the next phase, or well, not the next phase, but when we're imagine this is out in the field. So on the other side of the terminal blocks, that's where we're then going to put our cables to the light in the field. So now we're going to be moving on to the relay extensions. And you can see here, I'm getting, what I do is that they're all roughly going to be about the same length. So I measure, because these are going to the terminal blocks here. So I measure like the furthest point away, it will be this one. I measure the first cable. I go from here down here to the furthest point away on the terminal blocks, which will be here. And that's the length that I use as my data, my master cable length. Because everything else, like this cable, let's say this cable here is going to be shorter. We've already done the longest one, so there's going to be some excess cable that we cut off. We're going to be wasting some cable, but I don't really mind about that because it just makes this whole wiring a lot more efficient. This one here is going to be, it's going to be a shorter cable. So what I do, as you can see, I've just used that master cable. I've cut all the lengths. Then I've stripped one end, all at the same time, holding it in one hand, strip. Then I put the ferrules on the end, ferrule. Then I crimp the ferrule, crimp. And it's just like, what's the saying? Let me think of the saying. Yeah, this was taught to me when I was an apprentice. It's far more efficient to do one thing 10 times than it is to do like 10 separate things once. So I've always worked to that principle, and it's served me well. So you can see these are all the cables cut. Now I'm just, because then I can just do everything's cut, everything's stripped, everything's crimped. Then I can just terminate them all at the same time, or terminate one, dress it in here, terminate the next one, dress it in here. It makes things far more efficient. And I'll explain the neutral with the images in a second. But that's the first lot of relays dressed in. You can see I put them all, connect them all to the terminals, then I take the cable, dress it in, and it's just a good, efficient way of doing things. Yeah, it's just photos that I'm taking from now on. So let's just have a look at the wiring quickly. It says mini server here, but it's the same principles for a relay extension. So I'll talk about the neutral in a second, but ultimately we had the feeds already in place going into the mini server or the relay extension. What we've just wired then is the switched live going out, and we just got to imagine we've wired into the terminal blocks here, and then on the other side of the terminal block, the cables out in the field are obviously going out to the light. Right. Just a second. Yeah, so yeah, I mean, it's pretty self-explanatory. We've already explained what's going on there. Those are all the neutrals for the dimmer extensions. They've got the dimmer channels from the dimmer extension. They've got their own separate neutrals. And then, as you can see here, we're taking a neutral from the RCBO directly, and then we're, as you can see with these connectors here, these little buzz bars, from terminal block 9 to 14, we're using the neutral from, let's just say, RCBO 1. I'm not sure if that's the exact one, but RCBO 1 is for all of these switch devices, or lights most likely, and then we're using, I think it's RCBO 3 for all of these ones. So we got a new terminal buzz bar, and you can get these at all different lengths from Vargo. But yeah, it's then distributing that neutral across 15, or from 15 where we got the supply, or the neutral supply feed, whatever you want to refer to it as, and then it's being distributed to 22 here. Yeah, another image. Have we got one of the RCBOs? I don't think we do. But yeah, that's basically what's happening. Yeah, that's it for that video.
Okay guys, now I'm going to focus on the terminal blocks for the audio. So I'm going to wire from the audio server and stereo extensions to the terminal blocks, which are then of course going out to the speakers in the field.
Okay, on to the next one. Wiring the outputs of the audio server and this stereo extensions. Again, similar principles that I mentioned already. I get basically, maybe I don't do it so much with these ones, where I get a master cable, go the longest route, and then use that as a master, and then cut everything from that, because as you can see with this stereo extension to say this point on the terminal block, that's going to be quite a lot shorter. I can't remember what I do, but I am wary of wasting too much cable, but most of the time, in my mind, it's more efficient just to waste a bit of cable than it is to cut everything its individual length. It's better just to do it in bulk as much as you can. So yeah, that's the first lot of cables in. You can see, yeah, I've done it bulk now for, so I did a batch there. What was it? 4 reds and 4 blacks. And then I think I did 3 reds, 3 blacks. That's that batch, and then I'm doing another batch. There you go, I just did a quick measurement. Yeah, it's just so I'm not wasting as much cable. So 3 different masters, if you like. Starting to really come together, this panel now. And that's like the default color that I use for audio, is red and black. So that's usually what you have on speakers out in the field. You know, it's normally red's the positive, black's the negative. So that's that wired in. Let's have a look at some images. So yeah, when I mean, like, that was the first batch that I did. So I measured to put a cable from here through the trunking to like this point here, I think it was, and then I cut 1, 2, 3, 4 reds, and then with the same master length I cut 1, 2, 3, 4 blacks, and then again just making things more efficient, had them all in one hand, use my strippers, strip, then I put the ferrules on, ferrule. Then I use my crimper, crimp. Still got them in my hand. Then I can just, as they're in my hand, I can just take, oh, there's a red, screw that into the terminal. There's the black, screw that into the terminal. And then I can dress them in, you know, sort out the tails, dress the tails in, and then basically, yeah, do what I need to do on the other end. And then, yeah, same, I did another batch, 1, 2, 3, so it was 6 reds and 6 blacks, and then the same thing, another batch for these ones that are a bit closer, that are going from here, you know, here, this was the master, maybe to here. So yeah, that's what I meant by that. Hopefully that makes sense. You can see they're all nicely dressed into the terminal blocks, ready to go out like obviously the audio cables going out to the speakers will be, you know, say there's a speaker out here and then the cable will come in here through the bottom panel entry. We'll be knocking out some of these holes. Yeah, and then just going straight into these terminal blocks. That looks nice, doesn't it? That is a nice swoopy bit of cable. I like that a lot. And there's method in my madness of the order in which that I am wiring everything that you've seen so far. It's because I've genuinely thought it out, and it makes sense to do it the way that I have. So you've not got like loads of crossover of cables in the trunking. It's easy. Let's say that you wanted to get to, you know, some of these cables here. Well, you can just basically, these ones that are running on top, it's just easy just to kind of move them out of the trunking for a second. You can access all of these cables below and then just nicely put those back into the trunking. Like, if you don't think about this sort of thing, then things are going to be like crisscrossing. There might be crisscrossing of these cables with these red audio cables, and then it's just a mess. It's just horrible. So, you know, and this is why you've got these still left out here, ready to terminate here, because they'll be the final things that run in this trunking here and then go over the top of everything else. So that's another thing to consider is, you know, you want, it's the same principles with the terminal blocks, but even more so, because it's just, yeah, super messy otherwise, hard to trace cables if you do need to get into the panel and trace cables back. Yeah, I'll stop rambling about that. But yeah, looking very nice, as you can see. Take a lot of pride in the panels that I design and build, because I think it's like a piece of artwork. You know, you've got a blank canvas of a panel enclosure, and then it's up to you to, you know, design the layout and then wire it, you know, strategically, logically. You know, nice swoops on the cables. Yeah, you know what I mean. So, yeah, get quite passionate about wiring panels. What was I going to show you? Yeah, so part of the resources, just talking about cable colors. You can see this is the CAD layout that I designed previously, which you can have access to this if you got access to the resources and all the CAD files as well. But as you can see here, I'm pointing out the cable colors. And for the extra low voltage, which is obviously the audio, we got red for audio positive and we got black for audio negative, and obviously everything else in there as well. And then what we just wired here, or what you just saw me wiring, is all of these. And these are really nice space-saving terminal blocks from Vargo or Wago, whereby, let's have a little closer look. It's one terminal, but you've got like the positive and the negative in one terminal. So rather than two, you know, like 1, 2, one for the positive, one for the negative, it's all in one. So it saves a lot of space. Because, you know, there's a hell of, if I didn't use these, I wouldn't have enough space for all of my terminals. And then what do you do? You know, so these are amazing terminal blocks from Vargo, Wago, because they save a lot of space. But you can see here, so AS1A, so audio server 1, channel A, is feeding the living room speaker 1. Audio server 1, or channel, sorry, audio server channel 1, I can't remember, but you get the point. Audio server 1, channel 1, side A. It makes more sense when you get to the programming, the software, which we'll get to later on. You know, that's feeding living room speaker 1. Then you've got the other one, AS audio server 1B, feeding the living room speaker 2. And then it's the same thing. Let's skip the audio server, move on to the stereo extension. So stereo extension 1, channel 1 is feeding the entrance speaker. Stereo extension 1, channel 2 is the garage speaker, and so on and so forth. So there, that's it for this video. Hope you enjoyed it. See you on the next one.
Okay guys, so now on to the next stage, and we're going to be wiring the LED strip cables from the RCBO extensions to the terminal blocks.
Okay, on to the next video. And as you can see here, I've already cut my master cable, the cable lengths, because I've already worked out roughly, the length from here all the way to here, and I've already measured and cut them. What was really annoying about this is I didn't have, so these are RGBW, red, green, blue, white controllers for LED strip. And as you can see, I've got all the colors, and the orange that you see in there is the 24 volt DC positive power. But you can see here that I don't have the green, which is really annoying. So I had to order in some additional, an additional reel of cable, so I could have the green color in there as well. So that's the only thing missing. That's why there's a gap in here. I will later come back and do that when the roll of green cable arrives. But yeah, you can see they're all dressed in here, and then they're connected here, and then I'm dressing them in, swooping them round, as you can see, and then dressing them into these incredible terminal blocks, which I'll talk to you about in a little bit. So let's just have a look at some images to start with. So yeah, as I mentioned, RGBW. So we got the positive, or the main power, or it might even be the 0 volts. But I've got it here as the orange to indicate like the positive, and then we got our white, so our R for red, G which is missing, B which is blue, W white, and then they all swoop round and then connect into these Wiedmuller terminal blocks. And I'll show you these in a bit more detail in a second. Obviously you can see that we're missing the green at the moment, but that will be adjusted later on. So from up here all the way around here and into there, not much to it really. There's some additional images, starting to look really nice now. Yeah, all looking good, looking good. So let me just explain those terminal blocks. So this is the part number, and they're by Wiedmuller. This is the one that you want to look at, and as you can see, they're just straight through. So this bottom connector goes all the way through here to this other bottom connector, and it's, as you can see, isolated from this next one. Goes all the way through. That's isolated. They're all isolated from each other, but that's ultimately 8 different cables on one terminal space, one terminal width, which is again just saving so much space. How many spaces would that be if we didn't have those? And I know we're not using all of them, but that would be a lot of space. I wouldn't have enough space on the DIN rail, and yeah, it's not good times. And what you can see, so this is the wiring diagram, if you like. You've actually got 2 points. So you can, if you look here a bit closer, you've got, and these are push-in connectors that you can then release from pushing on these, but you've got 1 and 2 next to each other, which ultimately looks like this. So you've got a terminal point here, terminal point there, straight through these 2 points on the other side, and then you're galvanically isolated, where you've got the same thing moving along the terminal block. So you've got these top ones, and then you've got these next ones, and etc. etc. You get the idea. What that looks like, so what we're wiring here is we're wiring these blue, as we just saw, Wiedmuller terminals here. So, and let's look at an image quickly. So this is how we labeled them: 1, 2, 3, 4, 5, 6, 7, 8. So we're starting at 8. I think this is corrected later on, just so you're aware. But we're ultimately going, the 24 volt is the orange at the bottom. So 24 volts is here. Then we've got our white, blue, green, red. So yeah, 24 volts, white, blue, green, red, as you can see there. And being fed from PSU1, then going out to the living room LED strip 1, LED strip 2, living room LED strip 3. So basically PSU1 and let's just go back, and I'm not sure exactly which driver it is. Let's just say it's RCBW1. That is providing control and power to the living room LED strip. And then the next one, PSU2, so these are both 10 amp power supplies. PSU2 is feeding smaller lengths of strip in the kitchen, on the ceiling, but also the cabinets as well. So let's have a quick look at what that looks like on our cable layout. So we got our living room. That's one piece of LED strip. So living room LED 1, living room LED 2, living room LED 3. Yeah, so strip 1, 2, 3. And then we've also got a spare in there just in case. And then over here in the kitchen, I'll explain this in a second, LED 4. And then we got LED 1, LED 2 above the kitchen, like cooker and kitchen island stuff. And then you've got LED 3 around the cupboards here. That's kind of how it looks like in the field. And then you can see here on the schedule what we're interested in here is, so RCBW dimmer 1, that's the living room ceiling tray. So that's the first RCBW dimmer, this one. That's controlling that first piece of LED strip in the ceiling. So look, there's basically, if we zoom in a little bit, we got 3 bits of separate LED strip, but they all make up the, 13 odd meters of LED strip around the ceiling, around here. So that's like 13 odd meters, but we're doing it from separate separate cable runs. You got to do like your voltage drop calculations and things like that, and work out that you're not there's enough cable current carrying capacity in the cable and all of that stuff. You're not going to get voltage drop and whatnot. So yeah, that's why that's done like that. So yeah, RGBW dimmer tree 1, and for that first bit, and then 2, dimmer 2 is doing those second bits, and then you've got dimmer 3, so dimmer 3 here, that is then going to the ceiling tray in the kitchen, and then this final dimmer 4 is again going to the kitchen, but for the cabinets rather than the ceiling tray. And as you can see, that's kind of how the power is split. And let's say that we have all of the kitchen LED strip on maxed out, then it's actually going to pull over the 10 amps of that power supply, which shouldn't be a problem. It might cause the controller, the dimmer, one of these to like just conk out. What we can do is you'll see later on in the testing videos, when I'm doing the pre-commissioning, the off-site, like testing and all the rest of it, I notch up the power supplies as much as I possibly can, or not too much, but as much as I can, which gets it higher than the 10, or sorry, we're notching up the voltage, aren't we? But anyway, it's just here to indicate that, you know, basically we're just on the edge of the current that we can supply if all of those LED strips are on, maxed out with the full RGBW colors on, which is very rare that happens, but that's why it's orange. That's why if we look here, I've made this orange just to sort of indicate that it's something to be aware of, basically. Bit of a ramble on that one, but yeah, that's it for that video.
Okay guys, so that's the bulk of the terminal blocks now wired, but we still got a few more that we need to do. So what we're going to look at now is the ventilation boost signals and the ACO fire alarm trigger signal, the valve open feedback signals, the Horman garage door feedback signals and control signals, the Winkhouse door lock control signal, and then finally the terminal block for the link cable connecting Lox1 and Lox2 panels.
Okay, next video. So what you'll see in a second is, yeah, the yellow cables that we're using, like these are volt-free cables, and what we're putting in here are the control for the ventilation boost signals. So let's say that, let me try and find these as well. So yeah, what we just wired in there is the ventilation unit 1 boost and ventilation unit 2 boost, mini server relay 1, mini server relay 2. So like if high humidity is detected, or yeah, just let's stick with that. High humidity is detected, or high carbon dioxide is detected, then we can boost the ventilation system automatically, and that's how we do it with those volt-free contacts that are wired from the relays of the mini server. Now what you can see is we're doing digital inputs for, let me just double check, yeah, so this is the digital input for the ACO relay alarm base. So like if the fire alarm triggers, the ACO fire alarm triggers, it then can send a signal back into the Loxone control system, we can detect that, and then we can program a load of things off the back of that, like turn the lights on, open the blinds, open the windows, unlock the doors, etc., etc. Because it's like an emergency. We want, you know, certain things to happen off the back of that, so we can detect that through that digital input signal. So yeah, mini server digital input 3 is that ACO relay based alarm trigger. So yeah, as you can see, just adjusting the terminal blocks. What am I doing here? Let's go back. So here what I'm doing is I'm just adding, because now we're going, these grey terminal blocks are similar to the blue ones, but rather than being galvanically isolated, you know, like this side to this side, section 1 is galvanically isolated from this side and this side, section 2. The grey terminal blocks, they're all, if you put, say, 24 volts in, it's spread across all of those terminals. So it's like they're all common together. So I think what I'm doing here is I'm putting a 24 volt DC and 0 volt supply from the last extension in this panel that's then going to be going off to the second panel. So that's been put in. And now what you can see here is I'm adding some additional inputs into the mini server. So let me just double check what they are. 2 secs. Yep, so as you can see here on the schedule, these are the valve feedback signals. So when the valve is fully open, we can then send back a signal to say, yep, that's fully open, now we can switch on the pumps. You don't always have to do it this way, but this project required it to be done like this, basically. So you can see digital input 1, digital input 2. So that's what I'm doing there that you can see at the moment. Let's fast forward a bit. Yeah, and these additional volt-free contacts and relays, what are they being used for? Let's have a quick look. So yeah, as you can see here, garage door open signal, volt-free, mini server 1, relays, channel 3 and channel 4. So, you know, if we're using an app outside the home, or you know, one of these wireless remotes in our car, maybe we can just press a button on the remote or in our app that sends a signal back to the controller that that then sends a signal of, you know, to the garage doors to open it to let us in as we're coming home from, you know, being at work or whatever. So a few more digital inputs. You saw me there adding a 0 volt distribution off on these grey terminals. And now we're also, as you can see, the blue twisted pair, blue and white twisted pair, we're also continuing that link communication out from LOX 1, this panel, to LOX 2, where we've got additional controllers that we need that, control signal from the main mini server that's already going, it's already going where it needs to go, and now it's off here to then go to the other extensions in the second panel. So that's what we just added in there. Let me show you some images quickly of what I've just been through, and then I want to come back and explain this. So this is the tree lines out to the field, and as you can see, we kind of skipped over this part because it's quite tricky to explain, but I'll do my best to explain that in a second. But yeah, there's those volt-free relay connections, just swooping from, or coming from up here down here. It's all pretty self-explanatory. These are the grey terminals, similar to the blue ones, again by Wiedmuller, and you can see all they do, they are galvanically isolated, but they put these little, what would you call them, buzz bars across the metal terminals that commons everything together. So what you can do, let's say that you run out of the blue Wiedmuller ones, you can get these, you might have some stock left of these grey ones. You can just pull these connector bits out and they work the same as the blue ones. There you go. You can just pull those out and now they function the same as those blue ones. All of these are galvanically isolated from each other. Whereas with those in, they're all common together. So there's that 24 volts being distributed out. So what I mean by, so we've kept them intact. So these connections are in, they're in. So if we got 0 volts on this side. So every terminal has 0 volts on it. So we can put like multiple cables into 62 and it'll be 0 volts, and we can put multiple cables into 61 and it's the positive 24 volts. So like it's just like a way of distributing quickly and easily with multiple points to go into, your 24 volt DC. Those are the digital inputs. There's a collection of different digital inputs, digital outputs, all volt-free. We can have a look at that in a bit more detail in a second. We got our Winkhouse 12 volt door lock in there as well, and then we got our Loxone link going out here. So it's a bit, I understand it's, without taking time to study the documentation and resources, it's a bit tricky to explain and understand from these images. You kind of need to just interpret it yourself and see what's happening from referencing the resources. But yeah, that's basically the panel now pretty much wired, other than a few additional bits. So let me try and explain, let's just go back. Let me try and explain these tree lines, what's going on here. So, and forgive me if my explanation does not, hang on a second. Don't know why I'm getting phone called. My phone is set to work mode, but for some reason, people are getting through to me. Don't know how. So anyway, I'll try and explain this, but it's a little bit tricky. You kind of have to interpret this yourself. Pictures paint 1,000 words. The documentation will help you understand this. But let's go with, so this one here, 49. LOX line 1 and 2. So let's go here. So Loxone tree zone 1 and Loxone tree zone 2. So that terminal block 49, where is it? 49. Let's try and get a better picture actually. That might be the best picture we got actually. Yeah, here we go. So terminal block 49, it's being fed at least the 1.5 millimeters. It might be helpful if I explain tree cable quickly. 2 secs. Yeah, so this is Loxone tree cable. So it provides your tree comms, which we should already be familiar with. We're keeping the cable consistent outside the panel and inside the panel. So twisted green and white is the tree comms, and then we've got the twisted orange and white, which is the low power, low current, like peripheral power. So peripherals are things like the motion sensors, the touch switches, the things that don't consume much power. And then we've got the thicker 1.5 mil cables for that require more power, things like the lights, the RGBW spots. So hopefully that'll give you a bit of context. So that's ultimately what we're matching here. We've got the tree comms, so let's say that's white, tree comms, that's green. Then we got the 0 volts for the peripherals, white twisted with the orange, the positive, and then we got the same thing, the white, this is the 1.5 mil cable, and then we got the 24 volt, which is the orange 1.5. So what we're doing here is 49, this top one, number 1, you can see is the white tree cable. So we would go in there, or in one of these, or we would connect this tree cable. You know, there's six points, 1, 2, 3, 4, 5, 6. We would connect that in here. You know, well, as you can see, 1, 2, 3, 4, 5, 6. You know, to the relevant bit, and then that line. So we got line 1 and we've got line 2. So line 1 would go into, as you can see, we got 2 points here. 1, 1, 1, 1, 1, 1 on the left hand side, and then we got 2 on the right hand side. So that's why we can have 2 lines branching off here. Yeah, LOX line 1 and 2, which is ultimately going off to this zone, the living room, and then this zone here, the kitchen. So that's like the cable coming from the panel that is connected into that point that we just explained, and then there's additional wiring out in the field going from this spot to this spot to this spot to this motion sensor to this spot, etc., etc. And then we also bring a cable back just as a spare, and for redundancy. So that's ultimately what's happening on terminal block 49. What we're doing differently on 50 and 51, so as you can see, 50 and 51, we're looping the tree comms. So we got the feed coming in here from the tree extension, and then we're looping into this next terminal block 51, and that carries that same tree comms across all 4 of these terminal points. And we're doing the same with the green, and then we're doing the same with the peripheral 0 volts and 24 volts. So we're doing the same thing with this one here. Okay, we're looping. We're looping. You won't be able to see it, but we're doing the same thing. We're looping with the twisted orange and the twisted orange and white. And then for these thicker cables that's going to be powering the lighting, on this configuration, we got, as you can see, PSU3 that is coming from here. So what we're probably doing underneath the cabling, you won't be able to see it, we're looping from here over to here. So we're just carrying that PSU3 power over to here, or we might be running it directly from the power supply. I don't think we are though. We're just looping for on terminal 50 for the 0 volts and the 24 volts, the 1.5 cable. But then for 51, we got a new supply from PSU4. Okay. So yeah, this is where it gets a little bit difficult to explain. But yeah, you can see PSU4, the 1.5 mil cable. So this is the 10 amp power supply, is providing then power to these terminals as well, 52, 53, 54. So we're looping over, and providing power to LOX zones 6, 7, 8, 9, 10, and 17. Obviously, we're doing our power calculations as well to make sure that we can do this. We're not going to sort of have an overcurrent. We've done all our calculations and whatnot, and yeah, it's just a clever way of distributing power whilst distributing the comms from the Loxone tree extensions in a slightly different way. A little bit complicated to explain, but it will take time to sort of like look at the images, look at the documentation in Loxone, you know, the tech manuals and stuff to understand what's going on here, and yeah. But that's all sort of all the information, all the documentation that I've done is in the resources. So it might take just a bit of time to get familiar with all of that. Yeah, and I think that is it for this video. Yep.
Okay guys, so we're pretty much there now with the wiring. There's just a couple more things we need to do. The first thing is the Ethernet cables from the RJ45 straight through connectors to the mini server and audio server. And then finally an earth cable from the earth bar to the enclosure, just to make sure that that metal closure is properly earthed.
Okay guys, nothing to this video really. As already mentioned, Ethernet cables to the audio server and the mini server coming from these Wago RJ45 straight through connectors. Now you might be saying, "Oh, Chris, why are you cutting Cat5, Cat6 cable? Why don't you just use patch leads?" Well, I did look at using patch leads, but you can never get them to the perfect length. You know, I think 0.2 of a meter, half a meter, 0.1 of a meter. Anyway, I think I did have the closest, or the smallest size needed. But you can see this is the problem with these future automation panels. You can't change the trunking. And you can see here, you know, this is a big panel. The trunking isn't really big enough for all the cables. So I didn't have hardly any space for that access cable of the patch lead really to run in. I suppose you could have done. But yeah, there's not much space for excess cable, especially a thick cat cable, to to have access in the trunking. So I just decided to just cut them to length and make them the perfect length inside the panel. But it is a bit of faff, you have to, it is faff, don't get me wrong, faff, cutting and stripping and getting a cat cable into an RJ45, and getting that all crimped, and then making sure it's tested and there's good connections. Like, if you can, you should probably just use a patch lead, already made up Ethernet cable, end to end, already tested. If I was to do this again, I probably would do that and just make sure that I'm running the excess in a piece of trunking that's got not much cable in it. But yeah, there's not much to this video. As you can see, gone from the Wago terminal blocks, and now I'm just testing it. As you can see there, just testing it, which we will go through the testing later on in more detail when we get to the testing phase. But yeah, that's the Ethernet cable done. And then I think up here you can see I'm just putting a nice thick earth cable in. Let's go back. Yeah, nice thick earth cable that you can see that's getting a really solid connection from the earth bar to the panel, to the enclosure. Not really many images to look at. Well, there is, because I took a load of images of the finished panel, admiring my masterpiece. But yeah, there you go. You can see that's for the mini server, I'm pretty sure, and this one is for the audio server. So we've got that network connection, and that's what it looks like. Nice little tip with these is run it out, rather than, as you can see with these ones, you're coming out of this face of the trunking with these fingers. What I'd recommend with the Ethernet is go out the back to then go over the top of the trunking lids. It's a much nicer swoop. As you can see, same thing with the mini server. And yeah, nice thick cable earthing the earth bar to the enclosure. Now these next photos, you can just see I'm admiring my work and just taking some shots of the finished article, because this is all the wiring done now, before the trunking lids go on. That's a really nice photo, isn't it? That looks tidy. From a different angle, from the top. So yeah, obviously if you've got access to the resources, you get all of these images, including all the finished images as well. For Lox 1, we're going to be moving on to Lox 2 panel in a second. We're going to go through the building and wiring of all of that. You got the ready to ship images as well, so you get access to all of that if you've got access to the resources. Pictures paint 1,000 words, and if you got all the documentation as well, the final documentation in the documentation pack, you've got all the CAD files. You got the project folder, like the architect designs, all of my designs. You've even got like the financials, the costings, the proposals, all of that broken down. Tech manuals to the things that we're controlling, underfloor heating plans from the heating contractor, and then you've got the whole programming, which we get into a bit later on. But having access to all of these with this video training will paint a much clearer picture, because you can go through things in your own time. You can reference all the images. This is how I really learned commercial building automation controls and building management systems, is by doing things like this, taking photos of existing panels, taking photos of existing documentation, schematics, tech manuals, layout diagrams, and just taking some time off-site in my own time to really understand what is going on. And it does take a little bit of time. You know, it's all, obviously there was no one to explain things like I'm explaining to you now. But with this, it will also take a bit of time, you know, just you digesting things in your own time, you know, separate to what we're doing here. But yeah, you'd have access to all of this, all of these resources, yeah, in the Google Drive or wherever you're watching this training. Look at that, absolute masterpiece, if I do say so myself. Nice.
Chris again, that project folder that you just saw me referring to, that is just one of the resources that we give you access to if you join us in the full Smart Home Specialist training program, along with all the config files, the documentation, the full testing, commissioning and programming walkthrough as well. Just wanted to make you aware of it. Whenever you're ready, click the link in the description where you can learn more.
Okay guys, so now on to the second panel, LOX 2, and it's going to be a very similar process to LOX 1. So I'm going to go through this relatively quickly and only really focus on the wiring side of it. So I'm going to quickly skip over the panel preparation and the populating and labeling of the components, and then we'll just get straight into the wiring.
Okay, off we go. So straight away you can see that I removed the top DIN rail. For the terminal blocks, it's top cable entry on this panel, and then you saw back there that I just moved the neutral bar to this side because this is where the RCBOs are going to go. And then we got our energy meter, we got our Modbus and one wire extensions, we got relay extensions, and then we got a contactor for our immersion heater. And then just getting the tails in for our RCBOs. No need to cut. I mean, they're long. They're too long, really. But the trunking in this panel isn't going to be too filled up. So yeah, I'm keeping the tails their full length that come with the RCBOs, and then terminating them left to right on the neutral bar down below. So yeah, this is how the panels arrive from Future Automation, and that's what it's like out the box. Obviously took those standoffs, those feet off the top DIN rail. And yeah, that's basically what it looks like afterwards. Nice little trick or tip is with these fingers, if you want to keep cables down, you can just chuck them, you know, in between other fingers of the trunking, and it kind of wedges them down. Nice little tip there. And yeah, what I did is, you know, this RCBO goes here, this RCBO, the second one goes here, the second, and so yeah, you get the idea. I think that's it. Another angle, just showing you the tails. And so this was the first layout that I had, but I later realized, and I'll show you on the future videos why I changed this layout. But you can see here, this wasn't the original layout design. This is revision 2 because I changed things. But you can see that I ended up moving the immersion contactor over here, and yeah, to the left, and you'll see why I do that in a bit. Okay, that's it for this video.
Okay guys, so now onto the wiring, and we're going to focus on the RCBOs. So the tails, the neutral tails are already done and connected to the neutral bar, but now we're going to continue with the supplies from the RCBOs to the relay extensions and also the immersion heater contactor.
Okay, moving on to the next video. So as you can see, all of the labeling has been done. We've added in the terminal blocks, etc, etc. So that's already been done. Same method that we used on Loxone. And now what you can see is I'm just wiring in the feed from RCBO 1 to the first relay on this relay extension, and then I'm looping the supply in and out, in and out, in and out, in and out. So you can see the top row's pretty much done. And then we've also got the neutral, which will be going up to the terminal blocks up here. So again, we're looping again, we're continuing the loop, the feed from the RCBO 1. So yeah, we've gone from here in the supply side of the relay, and then double ferrule out, in, out, in, out, in, out, all the way to the last one on this row, around here, and then in and out, and then I think we're using another RCBO to supply these ones. So yeah, now doing the same thing for RCBO 2. Feeding relay extension 2. So you can see I terminated it initially. So this is now feeding RCBO 4, I think it is. 1, 2, 3, 4, feeding the immersion contactor. And I think this is where I'm like, I don't really like the position of this immersion contactor. And it will become obvious later on why that is. Yeah, so here we go. Yeah, it'll be easier to explain on the later videos why that is. You'll see, but I'm now moving the one wire and the Modbus out the way, taking all the terminals to the relays out. I've moved the contactor over here, and I'm just rewiring things. You know, this happens. You know, you don't always think about everything when you're doing the designs and the layout until you're actually building the panel. So yeah, it's not uncommon to do this. But yeah, so that's it, pretty much done for these initial RCBOs. And I'll explain in a bit more detail on the next videos about why I've moved this contactor. So let's just pull up the images, just get a slightly closer look. That's not the best image. This is an upside down image. But yeah, basically explaining what I've just been through. This is slightly better. But yeah, just the feeds coming from the RCBOs into the relay extensions. Same as the last panel, we're leaving our cables that are going to the terminal blocks just not terminated for the time being, because we'll do that all together later on and it will be much more neater, and we can align, you know, we can do like from terminal 1 to the last one, and it just looks so much neater and nicer. So we'll leave that for now. But you can see that I've labelled them, so I know, you know, what, for this one for example, what RCBO that neutral's coming from. Yeah. Cool, that's it for this video.
Okay guys, so on to the next stage of the wiring now, and we're going to be focusing on the inbound cables from LOX 1 into LOX 2. So those cables are the 24 volt DC supply going to the additional extensions within LOX 2, and also the continued Loxone link bus, and remembering to put a 120 ohm resistor at the end of the last extension.
Okay, moving on. So as you can see here, I kind of took a master length, and then I'm just wiring in the 24 volt DC peripheral, not peripherals, extension power. So the twisted pair, the orange white twisted pair, and I'm going from this terminal, and I'm going in, out, in, out, in, out. And I'm doing at the same time, you can see I'm doing exactly the same thing with the blue and white twisted pair for the LOX link, and they're both coming in on this terminal. So as you can see from this image, we've got the orange and white twisted pair on 8 and 7, and then we've got the blue and white twisted pair on 6 and 5. And then you can just see they're running in the trunk, in around here, in, out, in, out, in, out, and then at the end, I don't think you can see it yet. You can see here I've put the 120 ohm resistor, I've stuck it under this bit of electrical tape when I started the panel, just to remind me that that does need to go in here. But as you'll see later on in the testing videos, it doesn't always work, having a 120 ohm resistor. Although it's recommended from Loxone, it sometimes causes issues. So we put it in to start with, as you can see here. So I put it on of these connectors, I put it on the bottom, and that's absolutely fine like that. And then you just put the white and blue, obviously corresponding to the white and the blue on the top pins. So yeah, it looks like that. And then yeah, just put the cables over the top. So let me just show you the terminal blocks here. So this terminal block, what we've got, and we'll come back to this. But yeah, top cable entry. This is the LOX 2 panel, and you can see basically going or coming from LOX 1 control panel. And as I just mentioned, we've got 0 volts and 24 volts on 8 and 7, and then we got the Loxone link on 6 and 5. So it comes in on those and then goes straight through and goes out on the corresponding number, and then this is where we're now in the panel, and then we can take that to all the relevant points in the panel, which I just explained. So yeah, so what we're doing here is we're coming from LOX 1, and you can see here's the Loxone link, which is the communication from the mini server to all of the extensions. So we're continuing that communication out on this terminal. So we'll have a cable that goes from here out in the field and then terminates here, and then the same for this 24 volt DC. We this is the positive with the orange, this is the negative with the white. So we just put a cable in here. You know, it might be, well, it's most likely, if I remember correctly, the same cat cable, carrying the Loxone link and the 24 volts. And same with the 24 volts, that will then come in here and then be distributed. So I've drawn a little image here. just to reiterate, so yeah, we got Loxone panel in the plant room over here. This isn't like for like, it's just a demonstration. And then we got our Loxone 2 panel in the garage. So I'm just going to use blue for the link. So we've got, and obviously this will be running differently in the panel, but this is just to illustrate what I'm talking about. So we go from the mini server to extension 1 to extension 2 to extension 3, and then from extension, actually let's go around the other side, from extension 3 into the terminal block. And then we're going, this is the communication for the extensions, and then because we haven't got another mini server over here, you know, this is just a one mini server project, we want to extend that link. So cat cable, let's just draw a cat cable. Cat cable, you know, multi-core cat cable has 8 cores in it. Okay, and then one or two of those cores is the blue and white. So we're continuing that. That's obviously in here, over here, to this other panel, connected to the terminal block, and then we're using that twisted pair here, continuing that. Let's go over here, continuing that to extension 4, extension 5, and then we've also got that 120 ohm bad looking resistor, but we got that 120 ohm resistor, or let's just do it like that, 120 ohm resistor on that last extension. And it's pretty much the same thing with the 24 volt DC power supply. So we've got a dedicated power supply. We've got a dedicated power supply for all of the control and extensions within the panel. So you can see just about here the label PSU Lox extensions. So that's feeding the mini server, all of the extensions, and the same thing, we're going to come out of Lox 1 panel into Lox 2 panel with that same 24 volt DC. So it's going something like this. So 24 volt DC to the mini server, to the extensions, like this, over to the terminal blocks. This is the orange and white twisted pair, so we've got the positive 24 volts and the 0 volts. And again, we're going, this is the cat cable. We might have used a separate cat cable for redundancy, can't remember, but we're picking up again 2 cores within the cat cable, goes like that, out the other side. So now we're in the panel, and this is what you're seeing now, is these orange and white twisted pairs. So yes, go on the top, so to this extension and then to this extension. So that's just how we're distributing the Loxone link communication from the mini server to all of the extensions, and the 24 volt DC specifically for the controllers, the modules, the Loxone extensions, however you want to refer to them as. Cool, so that's it for this video.
Okay guys, so now on to the Modbus and one wire wiring within the panel.
Okay, on to the next video. So this here, you can see that I've got the blue cable. This is really thin, solid core cable. This blue one's going to be for the Modbus, from the Modbus extension to the Modbus energy meter. And you'll see on the images in a second, I cut one to length, and then I cut another one, and then what I'm doing now is I'm twisting them together with a drill, and you'll see this more clearly in a second. You see I'm terminating at the Modbus meter, and then I'm doing exactly the same for the pink cable for the one wire extension, going from the one wire extension to the terminal block. And the reason I'm twisting these pairs is it reduces interference and noise ingressing onto these lines. These are like super sensitive analog, well, what do you call them, analog? They're super sensitive signals, and they're running, as you can see here, they're partially running next to some higher voltage cables, and this is partly why I moved the immersion heater. I can't remember what the immersion heater pulls in terms of current. Let me just check. Yeah, immersion heater will pull like 13 amps. So if you can imagine, it's not necessarily going to happen, but I'm just provisioning for potential problems. That's pulling, like, that's contacting, open and close, and it's not likely to be on off like that. But I'm just mitigating any risk. That's got 13 amps running across or running on these cables, which are going to be running in the same trunking, and you'll see how I segregate them in a bit to reduce that potential. But you've got those cables running next to each other. They're not crossing like that. They're running parallel to each other. So I want to reduce as much as I possibly can any potential for that noise that's generated, from that contactor pulling the immersion or switching the immersion on and off. I want to prevent it as much as I possibly can being induced onto these cables because they're sensitive. So that's why I've twisted those pairs, and you'll see later on how I segregate the cables on the outbound side of the contactor to these cables. But here you can see that I'm just double checking. I'm belling out the one wire individual cores to make sure that I'm putting them in the right place on this terminal block. So let me just show you some images. So yeah, you can see here they're both twisted. So 3 cores for the one wire, then going into 1, 2, 3, and then the same with the blue cable from the Modbus extension, 2 cables twisted, and the Modbus cables are going into this Eastron energy meter. And I think that's pretty much it. Yeah, not really much more to see. Let's have a look at this. So we've already talked about the 0 volts and the 24 volts and the link coming in and then being distributed in the LOX 2 panel. But you can see here, this is the one wire D. These are the different cores: DQ, ground, and VDD. One wire DQ, one wire ground, one wire VDD. We're connecting in here, and then the outbound cable to the temperature sensors, which is what we're using one wire for, will then be distributed along the one wire cable infrastructure out from here. So if you're not familiar with one wire, ultimately you can use it for what we're using it for here is temperature monitoring. So monitoring underfloor temperature. So because we're using underfloor heating, so we want to monitor the underfloor heating, and also you can put it on pipe work as well, just to see flow and return temperatures from the boiler. Not so much on a domestic property like this, a small domestic property, but certainly when you're doing larger scale commercial building control, you want that sort of data because you might want to be modulating the boiler based on the demand, based on what's coming back on your return, and basically making it as energy efficient as possible. And then if you look at the temperature probe one wire and then the temperature sensor, they're slightly different. So you got 4 cores, I'm not sure if you can see that, white, brown, green on this temperature probe, and then on the temperature sensor you've got this chip here, and then you've just got, you know, ground, GND, and your DQ, so 2 cores. So because you can see that these sensors, some of them use all 3 of these connections and some of them use 2. You know, there's 2 being used here, the DQ and the ground, what we just looked at with that temperature sensor, but then the temperature probe uses all 4. So yeah, we've just wired all of these in pink to the terminal block, and then we can decide later on. I can't remember if we're using a combination of both or just one type, but they're all there as an option. You know, that's the best practice. And then the Modbus device, pretty straightforward. We've got A and B. This is obviously our blue cable, our blue twisted pair, and it's just going out from A and B to our Modbus device. And in this case, our Modbus device is that Eastron energy meter. And then you can see here also that it's saying on the final device that on the line you should use a 120 ohm resistor. Yeah, similar to the Loxone link communication. Yeah, so that's it for that video.
Okay guys, now on to the next section where we're going to be wiring the outputs of the relay extensions to the terminal blocks.
Okay, on to the next video. So this is a pretty straightforward video. We've wired in all of the supplies to our relay extensions from the different RCBOs. Now we're wiring the outbound side, the switched live, which is going to be controlling things like our boiler, our manifold pumps, so our underfloor heating manifold pumps, our tower rail valves, our domestic hot water valves, extraction fans, and then we've got a load of outside external heaters as well, and outside external lighting too, and then we got a water pump as well. So that's kind of what all of these relays are doing. As you can tell, they're all HVAC related, or they're related to things outside. So yeah, pretty simple. As you can see, the trunking's getting a little bit busy already. Again, it's just the makeup of these future automation panels. It is what it is, but it would be nice if the trunking was a little bit bigger, but you know, you can only do so much. So all of the lives are going in, as you can see down here on the bottom. So all the switch lives now doing, so we've done relay extension 1, now we're moving on to relay extension 2. And yeah, as you can see here also, we're adding in the cables to the immersion to switch the immersion on and off. And what you can see here is I was just putting some cable ties in place, and as I was referring to on the previous video, is like segregating these sensitive, let's call them analog signals on the Modbus and one wire extensions in the trunking that are running, as you can see, on the top of the trunking. These thicker cables that are going to have like higher current running in them, let's make sure that they don't run anywhere near those sensitive cables. So I'm tie wrapping them, or tie wrapping the live and the neutral to this side of the trunking, and making sure that where these sensitive cables come into the trunking, they're running like at the bottom, and as they come into the finger trunking, and the immersion heater cables are running like at the top. Again, just making sure there's as much distance as possible between those two cables or types of cables. And then now you can see that I'm just adding in the neutrals. Actually, what you can see here is I'm just wiring in the control, so the A1, A2 side, because it's basically like a relay. A contactor is ultimately a relay. So we're just wiring in the control side, A1, A2 there, coming from a relay extension. And then we got the supply on here coming from an RCBO and going out here. And then you can also see, am I wiring the neutrals as well? Maybe not on this video. I think here I'm putting a 120 ohm resistor into the energy meter, which was really, really difficult and really, really fiddly. Cool, let's move on to the images. And it doesn't show the wiring of the neutrals in this video, but you can see we've got the neutrals in as well. And as you can see from this supply neutral from 3 to 12, that is the neutral going out to all of these devices. We don't, or lights, I think it is, or valves, or whatever it is. And so we don't need multiple cables coming in or looping in and out. We just use a nice piece of buzz bar, and that's distributing that neutral there. Yeah, similar thing with this one. And this is it, pretty much wired, ready to go. There's a couple more things I think that you'll see on the next video, but yeah, that's ultimately the panel wired, ready to go. Some classy or artistic shots there that you can see. But yeah, that is pretty much it for this video. Yeah.
Okay guys, now on to the final stage of the wiring, and that's going to be connecting the neutrals to the terminal blocks and then busing across to the relevant terminals that share that neutral, and then also making sure that there's a solid earth connection from the earth bar to the metal enclosure.
Okay, on to the next video, and I got a bit ahead of myself on the previous one. As you can see, this is the video where we go through wiring the neutrals and also adding in, as I mentioned, the solid earth connector. But yeah, just wire. These are just the feeds from the RCBOs. Pretty self-explanatory. They're already there. They're already labelled. I'm just terminating them now over the top, just so it's all nice and neat. Not crossing cables. We're just doing all of the cables at the same time. And you can see those buzz bars, as already previously mentioned, and then you can see that I'm doing the earth cable now, and I think you can see I've just ripped off the 120 ohm resistor that was stuck there, and yeah, I'm just adding it to the Loxone link, as you can see there. And only one photo to show. That is the solid earth connection. Not that we're even using anything on this earth bar, to be fair, but it will be used later on when we got inbound cables or outbound cables. Yeah, because what happens is, just a second. Yeah, so what happens is we've got, I think this, if I remember correctly, this is like the main panel. Even though it's LOX 2, this is the main panel with the inbound like supply, because we've got, as you can see, we've got our energy meter here. So like the main feed is coming in here, and we're going to have our obviously our live, our neutral, going through the energy meter. Neutral is going to be connected to this buzz bar here. The earth's going to be connected here. So we want to just make sure that we've got a solid connection to the panel as well, because what's happening is all of these terminal blocks, you know, these are 230 volt mains terminal blocks, really nice terminal blocks from Wago. You can see in one terminal width, you've, rather than having three, so live, neutral, and then earth, you know, taking up three terminal block widths, Vargo have done, Wago have done it all in one. But you can see that we haven't got an inbound earth cable on this side. The earth, as you can see, the outbound earth that's going to be going to lighting circuits, HVAC control circuits, boiler on off, domestic hot water on off, controlling valves open and closed, is picking up the earth here, which is being picked up from like this DIN rail. So there's like metal hooks within these terminal blocks, and it's picking up the earth from this DIN rail. So we just want to make sure that, you know, we've got a solid earth connection feeding the enclosure, if you like. So yeah, that's one of the reasons why we've done that. And that's it for this video.
Right, I've got one more final thing to share with you. Now, I'm sure you know by now that the bulk of this video was pulled from a full 15-hour training course called Smart Home Specialist, where I cover absolutely everything to do with this project. The specifying, the design, the documentation, the panel builds, the testing, the programming, and the on-site commissioning. I've also completely pulled back the curtain on this whole real world project. You know, that's key. This is a real world project, sharing all of the financials, all of the numbers, plus all of the documentation and resources that you've seen me reference throughout this video. Now look, if you're an electrician, engineer, or business owner looking to understand how to install professional and highly profitable building automation systems, whether that's going into smart homes or commercial buildings, I can genuinely help you with that. So I'd really like to encourage you to visit the link in the description where you can learn more about that program I've just mentioned. But before you do that, there's a final thing that I'd like to share with you that won't be mentioned if you did visit that link in the description. So if you are interested, what I'm about to share with you is the introduction video taken from within the Smart Home Specialist training program, which will walk you through the goal of the program, why I put it together, the project that we're actually focusing on in more detail, and the whole course structure. So let me share that with you now.
Okay, welcome to Smart Home Specialist. So this course has been built to give you a realistic, practical understanding of what a full scope smart home project actually involves, and not just the theory, but the reality of design documentation needed, the build process, and the commissioning and programming. So what is the goal of this course? By the end of it, the idea is that you will have an understanding of the following. So all of the technical documentation and designs needed for a professional level smart home, how to produce those correct documentations and designs, a good understanding of the costings, how to put proposals together, how to, you know, work out the costings involved with those proposals, invoicing as well, the whole control panel build and wiring process, how to test and pre-commission control panels off-site, very important to do this build, wiring, pre-commissioning, testing, programming off-site, how to program the system off-site, and then all the things to be aware of when on-site doing the commissioning. So put all this together, this means that you'll be able to systematically deliver successful, professional, reliable, and profitable smart home projects to your customers. Now, the manufacturer that we're going to be using is Loxone. So if you're not familiar with Loxone, I'm not going to go into them for too much in this video, but if you want to check them out, you're not familiar with them already, you can just click this link here and it will take you to their websites and you can read all about them. I have no affiliation with Loxone other than the fact that I used to work for them, and I'll go into this in a little bit more detail when I introduce myself properly in a bit. But yeah, no affiliation whatsoever. Now, although some of the commissioning and the programming content in this training is specific to the Loxone config software, the project delivery principles, design approach, and panel build process taught can be applied using any system for any type of project. So just for reference, I've delivered projects across smart home, commercial BMS, and industrial sectors using a range of different manufacturers and systems, and the underlying project delivery principles taught in this training are always the same. Now, Loxone does have its own problems and limitations in certain areas, but it's probably, if I had to choose of all the systems out there, that's a professional grade that you can make a business using, and they give you trade discount and all the rest of it. The best one for new people coming into the industry to learn on is probably Loxone, and this largely comes down to three specific things. So the software is relatively intuitive compared to other systems. Compared to things like KNX, it's much easier to grasp. Now, there's obviously a learning curve to any of these systems and any software, but generally speaking, it's a lot more intuitive than other systems, particularly KNX. The app visualization on the front end is generated automatically as part of the back-end programming rather than needing to build this separately. So with some systems, you do all like the back-end programming behind the scenes, and then let's say that you want to create an app to visualize, for example, what's happening in, say, this room that I'm in. So the client can look at the office room that I'm in and then see that, oh, there's some lighting control, and they can change the lighting. Oh, there's heating control, and like there's a visual interface for them to interact with the system. Some systems you have to create all of that separately and then map it and programming it to the actual control programming, which is a lot more time consuming, a lot more faffy, a lot more of a learning curve, etc., etc. So that's another good thing about Loxone. And then thirdly, Loxone's proprietary tree and air technology significantly speeds up the time it takes to do commissioning. Now, you could argue if you're an expert in KNX and you've been doing this for years, then you might argue that, well, I can commission a KNX system in the same amount of time. But the idea is that using, and I'm not saying that it's always the right thing to use, their proprietary tree and air technology, but the idea being that it makes commissioning and just general understanding of systems, control systems, a lot easier and quicker. Okay, now this obviously isn't about me, this training, but I thought I'd just put this in there just for context, just so you know who you're listening to, my background. If you're not familiar with me already, my name's Chris Guyatt. You can click this link here and open my LinkedIn profile and see all of my background. And you can see here what I did working for Loxone. So yeah, my background in Loxone consists of a year and a half working there as a partner coach and in the technical support department. So supporting Loxone's partner network across the UK on various smart home and commercial BMS projects. Now, since leaving Loxone, I've worked on countless projects with my own business, including I was going to say a small number, but it's actually quite a large number of takeover jobs, rescuing systems that were badly installed by partners who didn't actually understand how to deliver projects properly, professionally, reliably, thus not helping them out, causing them a lot of stress, and a lot of them never, touching this type of technology again, going back to doing just standard electrical, and also causing a lot of headache for their clients. And then what would happen is, the client would just get fed up and call in a specialist like myself to put things right, basically. So part of the reason for doing this training is to actually help people understand the process of project delivery that isn't taught within Loxone on their manufacturer training, where you just learn how to do the programming. I'm putting this together to help people deliver, reliable professional projects, and as a result doesn't turn into a takeover job from someone else, and doesn't piss off the customer, and enables them to build, profitable businesses off the back of it. So a lot of takeover projects, but I've also delivered multiple smart home projects, BMS projects using Loxone, projects like this one, from start to finish. And obviously one of those projects is the basis of this course. So let's actually discuss the details of this project. So throughout this course, you're going to be following a real world project. I'm so heavy on real world projects, what happens in the real world, not just theoretical stuff, PowerPoint, all of that rubbish. This is actual real world system. And I've chosen this one specifically because of how comprehensive and instructive it is for you guys. So this was a self-build 3-bedroom house that the client bought a plot of land and then developed it from scratch using his own architects and contractors. He was basically the project manager of this self-build. Now, it wasn't a massive property, but the level of Loxone control and monitoring was about as comprehensive as it gets. So every system that could be controlled or monitored was. So that includes the heating, the hot water, lighting, security, access control, audio, gate control, energy monitoring, electric vehicle charging, blinds, Velux windows, ventilation, water irrigation, various things controlled outside like lighting and IR heaters. And I think the plan was later on to also have solar PV installed as well. So this was the biggest reason really as to why I chose this project to do this training course on, because it's just so comprehensive, gives you a good understanding of all these subsystems. And just to give you a realistic benchmark for a project of this scope, here's the breakdown in terms of like budget and time taken. So the budget was approximately 50k. And this is what within that budget, as you can see here, 35k was Loxone hardware. So things like the mini server, the main controller, extensions within the panel, motion sensors, RCBO spots, valve actuators, etc., etc. All of that Loxone hardware came to about 35k. Now this was free issued by the client, so I didn't actually purchase this hardware through Loxone. The client already acquired it themselves. And then there was an additional 15k in hardware and labour. So additional hardware, things like panel enclosures, relays, contactors, cable, terminal blocks, that kind of thing. And then labour in terms of design, commissioning, programming, time on site, etc. So that's the budget. And then what I did was I logged every single hour spent on this project from start to finish. And this totaled to about 188 hours, which if you work it out it's 24 8-hour days ultimately. And this isn't a figure that many installers track, but it's genuinely useful useful context for understanding what a project like this demands in terms of, you know, the time spent you know, doing things beyond just the design and hardware. Now, for more details, breaking down these numbers, the business side of Loxone smart home projects, and also additional opportunities in this industry, I highly recommend that you watch the next video in this training titled The Business Model. Okay, so when you finish watching this video, make sure that you go and watch this business model training as well. Yeah, it's about an hour-long training, really valuable, and you've also got the slides that I'm using in this training as well to reference quickly. But yeah, breaking down all the numbers. This is print screens of me actually tracking every single minute, every single hour spent on this project, and there's just lots of other things worth going through in this training. Now, the course structure has been designed for you to go through from top to bottom chronologically, which basically follows the natural project progression. So as you'll see, you know, looking at the training, we've got the video that I just mentioned, the whole business model, then we've got like the files that are relevant, and then I'm going through breaking down every other folder in the resources folder and explaining, you know, why they're important. And then the rest of the training here from 2 till 11 is going through panel build and wiring for panel 1 and panel 2, offsite testing and pre-commissioning, offsite programming, and then on-site commissioning. And then you'll see that we've also added in 2 additional bonus trainings called CAD Crash Course and the Design Vault. So if you do intend to do professional level designs using CAD, you know, you can take the templates that we've already created that you can access in here, and then you can modify them using CAD software, which is very simple to use, doesn't take very long to get up to speed. You can use those files that we've got and, you know, modify them yourselves, and you can get up to speed very quickly within an hour through going through the CAD crash course that we've included here. And then also, you know, if you're doing design work, documentation work, specifying work, we've also got a design vault here that it's basically a dump of all the things that I've been using to deliver projects over the last however many number of years that you'll also find very helpful. Now, just to finish off, prerequisites, there is no real hard or fixed prerequisites. This is, really for anyone that's interested in smart homes or using Loxone. Ideally though, people from a technical background, so, you know, electricians, engineers, technicians, contractors, you know, business owners in these fields. A familiarity with Loxone would be beneficial, but isn't required. And then also downloading the Loxone config software, which we're going to cover later on in this course when we get to the offsite pre-commissioning and the initial programming. So there's details there of where you can get access to that. Okay, so that is this is the beginning of the training. Hope you enjoy it. I put a lot into this training, and any questions, please don't hesitate to reach out.